On this, Dr. V. Arun Prasad and Dr. Gokarneshwar Sahu will be presenting their respective lectures. First, I would like to invite Dr. V. Arun Prasad, who is an assistant professor in Department of Food Process Engineering, National Institute of Technology, Rourkela. He received MTech and PhD degrees in agricultural processing and food engineering from Tamil Nadu Agricultural University. He has got more than 6 years of teaching and research experience in the field of food process engineering. He has 25 research publications, 10 technical popular articles, and one book. His research interests are in the area of post-harvest handling and storage of his commodities, fresh commodities, development of nano-packaging materials, design and development of processing equipments. Thank you, sir, for being here. I would like to request you to present your lecture about cold chain management of perishable foods. Over to you, sir.
Thank you, Abhipriya, for introducing me. So in this lecture, we are going to discuss about cold chain management of perishable food materials. Throughout this lecture series, we are discussing about technologies to extend the shelf life of perishable commodities, especially fruits and vegetables, meat, poultry products, as well as dairy products. So cold chain management is one of the important aspects regarding extending the shelf life of perishable commodities. So right from the harvesting until it reaches the consumers, when the temperature is maintained at a desirable low temperature, it is called cold chain. And the components to be look into it when we are transporting, cooling it, or storing it. So the commodities undergo a lot of changes. We'll discuss some of the changes associated with cold chain management and shelf life enhancement of perishable commodities with the help of cold chain management. So in this lecture, we'll be discussing about the importance of cold chain management, components of cold chain, as well as some of physiological changes associated with cooling of commodities, and the effect of low temperature, relative humidity on quality of perishable products, and some of important cold chain management gadgets which helps us to maintain continuous cold chain, and the use of IoT and blockchain technology in cold chain, and how it helps to maintain the commodity under low temperature. So to begin with, we'll discuss some of the importance of cold chain management in extending the shelf life of perishable commodities. So India is one of the major producer of horticulture commodities, and in spite of huge production in perishable commodities, we are losing a lot of perishable commodity due to improper storage facilities as well as cold chain gadgets. And the important thing is we are producing enough to feed all the population in our country. But even though we are facing a lot of people who doesn't have a sufficient diet or balanced diet, so this is due to improper cold chain facilities and improper processing level. So if you see India, the global hunger index score is about 28.5 in 2006 and has 15.2% is of population is undernourished. So the global cold chain logistics market is very vast, and it's valued about 159 billion USD in 2018, and it is expected to reach 585 billion in 2026. So India has a lot of advantage in producing perishable commodities such as fruits and vegetables and meat, poultry, and then milk product. So India is the largest producer of livestock, largest milk producer, and second largest producer of sugarcane, second largest producer of cereals, second largest producer of fruits and vegetables, third largest producer of coarse grain. So India is having a 20 different agroclimatic region, which helps to produce wide range of horticultural commodities, and we have the second largest arable land, and 22% of cultivable land is involved in production of agricultural commodities, and it shares about 11% of the total world agricultural area. And India is sharing 15 major climatic regions, and out of 60 type of soil in the entire globe, India is having 46 out of it. So these are some of the opportunities which gives us a significant opportunity to increase the production of perishable and horticultural commodities and other agricultural commodities as well. So in spite of such huge significant or importance in agricultural sector, India's annual losses of agricultural commodities, in according to the data from 2018, shows 92,651 crores rupees we are losing every year due to improper facilities. Out of this, perishable commodities such as fruits, vegetables, meat, fish, and milk is contributing about 50,473 crores. So which means half of the losses which is taking place in the agricultural commodities due to perishable commodities. So if you are able to reduce the losses from 30% to 15%, annually, we can save about 18.3 million tons of fresh commodities. It's a huge quantity. We can feed a lot of people, and we can increase the export to foreign countries. It will earn a lot of foreign exchange to our country. And in addition to this, the value of commodities which we can save by maintaining proper cold chain is about $3.9 billion every year. So cold chain is the sector, or we can say cold chain is the key sector which holds a lot of solution for address these problems of food losses, either directly by increasing the shelf life of commodity, and indirectly it gives a lot of opportunity for the farmers and traders to reach different parts of the globe by maintaining a proper cold chain facilities. And to begin with, what is cold chain? The cold chain is a temperature controlled supply chain. So we can call cold chain as a temperature controlled supply chain. An unbroken cold chain is an uninterrupted series of refrigerated production, refrigerated storage, and low temperature transport, low temperature logistics, and low temperature retailing. So it is used to preserve and extend the shelf life of commodities such as fresh agricultural commodities, fruits and vegetables, seafoods, frozen food materials, and other meat, poultry meats as well. The cold chain provides benefits such as reducing the respiration rate of commodity. So the first benefit we get out of cold chain management is it reduces the respiration rate of fresh commodities. As the respiration rate reduces, the natural senescence decreases. So which means we get a long gap to market the commodities, and it reduces transpiration. As the respiration rate reduces, it reduces other metabolic activities as well as it reduces transpiration, which means the loss of water due to transpiration is reduced, and reduction in ethylene production. So due to over ethylene production, or due to production of ethylene during the course of storage and during the course of transportation, we can expect the fruit to spoil soon when compared to low temperature storages, and increase resistant to ethylene action. So by making the commodity more resistant to the ethylene, we can extend the shelf life, we can postpone the senescence, and it decreases the microbial activity. So the spoilage due to microbial decay is reduced when it is stored under low temperature, and it helps to prevent a lot of nutritional losses, textural losses, and flavor losses during the course of storage and transportations. So the cold chain, as shown in the picture, right from the harvest, during the processing operations such as washing, waxing, or packing in the pack houses, and shipping, and during retail, and until it reaches the end consumer, it should be maintained at the desirable low temperature storage. So the components of cold chain. So the components which helps us to maintain the proper storage temperature, right from packing and cooling of fresh produce, food processing operations such as freezing and storage operations, cold storage operations, distributions to refrigerated containers or refrigerated vehicles, and marketing in refrigerated devices such as refrigerated display racks. So these are some of the components which helps us to maintain the low temperature. So pre-cooling. Pre-cooling is the important operation in case of cold chain. So we can say this is the first and foremost operations to begin the cold chain operations. So immediately after harvest, the commodity has to be cooled down to a desirable or optimal temperature by removing the field heat. As soon as harvesting, as soon as the product is harvested, if you are reducing the temperature to a desirable condition, it reduces the respiration rate and it reduces all of the metabolic activities which is going on. So it enhances the quality, it helps us to keep the quality, to maintain the quality of commodity throughout the cold chain. So the first step is the key point in maintaining the cold chain. If you fail to pre-cool the commodity, which means that entire cold chain it spoils the commodity throughout the cold chain. So immediately after harvest, when the field heat is removed, for example, if you are harvesting the mango at 30 degrees Celsius, when it is brought down to an optimal storage condition of 4 degrees Celsius, it remains under low respiration state for a longer period of time. That means we have an ample time to maintain the quality, as well as we can maintain the shelf life throughout the cold chain. So pack house facilities where sorting of immature fruits or overripe fruits, grading depends upon the ripening stages, and some pre-processing operations such as washing, packing, waxing can be done to enhance the quality throughout the cold chain. And the modern pack house facilities are gaining more importance nowadays. Each and every district, uh, um, each and every district should have a pack house for packing their commodity and entering into the cold chain facilities. So pre-cooling can be done in different methods. Mechanical pre-coolers are available, which use forced air cooling methods to reduce the temperature. This pre-cooling facilities are entirely different from cold storage facilities. The cold storage facilities are used to maintain the temperature, whereas the pre-cooling systems are used to reduce the temperature at shorter time. So once the commodities are immediately cooled after harvesting, it reduces the cooling load in cold storage. So it enhances the shelf life, or it enhances the keeping quality of the commodity during cold storage, in transportation and retailing. So the facilities needed for pre-cooling is entirely different from cold storage. The cold storage, as I said, it helps us to maintain the temperature. For example, if you are storing the commodity, in 2 degrees Celsius, it helps us to maintain the commodity under 2 degrees Celsius. Whereas in pre-cooling systems, the temperature has to be drastically reduced from 30 degrees Celsius to 2 degrees Celsius. So we need some additional components such as forced air cooling system. To rapidly cool the commodities, we have to force the air over the commodity to reduce the temperature. So the capacity of fan or the airflow rate inside the pre-cooling systems will be a little bit higher when compared to cold storage. And we cannot keep the commodities completely in cold storage, completely in pre-cooling system for a longer period of time, because as it has higher air circulation inside, it leads to weight loss. So apart from this forced air cooling systems, we have other mechanical cooling systems such as vacuum pre-cooling system, forced air cooling system, hydro cooling system, and portable evaporative cooling systems. And where it is not possible to cool the commodities using forced air cooling system or any other mechanical cooling system, we can use ice as a cooling medium to reduce the temperature immediately. As per now, there is no pre-cooling methods are adapted in our country. It leads to a lot of this is the reason behind a lot of losses during transportation and quality losses during storages. So if you are pre-cooling the commodity immediately after harvest, it's enhanced the quality throughout the cold chain. So the rate of cooling. So as I said, as we are discussing about pre-cooling, the rate of cooling is an important criteria to be taken into account when you are going for pre-cooling of commodities. As I said, the pre-cooling is a faster temperature reduction method. So as much as possible, the temperature has to be reduced immediately after harvest, which means once the respiration rate increases after harvest, the metabolic activity increases. As the result of metabolic activity, ethylene production will increase. So the ethylene which is produced will again enhance the respiration rate. So the ethylene is produced as the result of metabolism. Once the ethylene is produced, it again increases the respiration rate. So as soon as possible, if you are able to reduce the temperature and control the respiration rate, the commodity can be stored for a longer period of time. So this graph shows how the temperature can be reduced immediately. With the cooling medium. So you can see at the right hand side, the product temperature. So let us assume the temperature of product is 30 degrees Celsius initially, and the time required to reduce the temperature of the commodity as 15 degrees Celsius is half cooling time. So the time required to reduce the temperature from the initial temperature to half of the initial temperature is half cooling time, and 3/4 cooling time and 7/8 cooling time is also calculated in case of pre-cooling. So when the commodity reaches 7/8 cooling temperature, we can assume that it almost reaches the safe storage temperature. So the rate of cooling depends upon the rate of cooling of commodities depends upon the rate of heat transfer between cooling medium and the commodity, and the temperature difference between the commodity and the cooling medium. So initially you can see as the temperature difference between the commodity is higher, commodity and the cooling medium is higher, the rate of cooling will be higher. Towards the end of the cooling process, the temperature difference between the cooling medium as well as the temperature is getting narrowed down. So the rate of cooling will also be reduced. And the nature of cooling medium. So in hydro cooling systems, as it comes in directly in contact with the commodity, the rate of cooling will be higher. In forced air cooling system, the rate of cooling will be a little bit lesser than that of hydro cooling system. And the thermal conductivity of the commodities. So most of the agricultural commodities, the thermal conductivity varies according to the nature of the commodities. So depending upon these parameters, the rate of cooling will vary with produce to produce. And cold chain logistics. So in global market, cold chain logistic plays an important role in reducing the food wastage. Perishable food materials, which includes fruits and vegetables, dairy products, meat, need to be chilled or transported under low temperature to maintain its quality. So the cold chain logistic provides facilities to transform and processing of food materials to ensure ensure minimum losses in commodities. So farm to fork transportation, the vast global transportation network is required in case of in order to maintain cold chain. So we should have manufacturing facilities with refrigeration and low temperature storage facilities, suppliers, warehouses, retailers, consumers. So all these components should be given with some cold cold chain components. And the commodities can be the category of commodities will be varying according to the temperature has to be maintained during the cold chain. So frozen food materials such as frozen meat, frozen vegetables can be stored under 80 degrees Celsius and transported under 18 degrees Celsius, whereas chilled 0 to 10 degrees Celsius, mild chilled 10 to 20 degrees Celsius. Mostly the subtropical fresh fruits and vegetables are transported under mild chill condition, which is 10 to 20 degrees Celsius. and normal low temperatures transportation and storage is required for commodities such as onion, dehydrated foods, and other food materials. So frozen food materials, mostly we can see frozen meat, frozen poultry, all those food materials. So the basic principle behind shelf life extension of commodities using cold storage is the fresh fruits and vegetables are living tissues, so that are subjected to continuous change after harvest. So immediately after harvest, it stops enjoying the nutrients, some nutrition supplements from the supply from the mother plant. So immediately after harvest, it has to depend on its own reserve to maintain its metabolism. So some of the changes which is happening after the harvest are desirable. For example, ripening. Most of the changes which are happening after harvesting of commodities are undesirable. For example, ethylene production. So as the ethylene production is more, the senescence of commodity will be more. So our main goal in post-harvest cold chain is to slow down the changes as much as necessary. So immediately after harvest, when you are taking the commodity to pre-cooling, and when you are maintaining the same temperature throughout the cold chain, it reduces changes, most of the metabolic changes associated with spoilage. So after harvest, fruits and vegetables are detached from the mother plant. It can't enjoy any more supply of nutrients from the mother plant. So therefore, after harvest, fruits and vegetables depends on their own carbon and water reserves. So that is the reason for changes during storage and transportation. So fresh fruits and the fresh fruits and vegetables depends upon the morphological structure, or depends upon the plant portion from where it is harvested. The respiration rate will vary, and the storage techniques will also be vary accordingly. So based on that, based on the commodity, the optimal storage conditions will also vary. For example, the low temperature storages for apple, carrot, lettuce, the optimal storage temperature is 0 to 2 degrees Celsius, whereas for banana, the optimum storage temperature is around 12 degrees Celsius to 16 degrees Celsius. Whereas in case of perishable commodities such as meat, poultry, and fish products, the temperature is around minus 25 degrees Celsius to 18 degrees Celsius. So based on the respiration rate, the commodity can be classified into different category: low respiring, moderate respiring, high respiring, very high respiring, and extremely high respiring, depends upon the respiration rate. So if the commodity is producing 5 to 10 milligram of CO2 per kg per hour, it is considered as a low respiring crop. Whereas when the commodity produce 20 to 40 milligram of CO2 per kg per hour, it is high respiring commodities. You can see the examples such as avocado, carrot, and cauliflower, lettuce. Most of the leafy vegetables will come under high respiring commodity, whereas low respiring commodity will have citrus fruits, grapes, papaya, sweet potato. Some of these commodities, most of the tuber commodities will come under low respiring. Whereas extremely high respiring commodities, the material which are in active growth stage, such as asparagus, spinach, mushroom, Brussels sprouts. So these are some of the commodities which is having high respiration rate. So according to the respiration behavior, the fruits and vegetable can be classified into two categories. One is climatic and non-climatic. Climatic fruits, the fruits are slow respiring, slow and a large increase in respiration rate and ethylene production during ripening. Whereas the non-climatic fruits shows no significant changes in case of respiration, which means it is low respiring commodities. So this is the graph which shows the difference between climatic and non-climatic fruits. So the commodities where the respiration rate declines after harvest is non-climatic fruits. Whereas in climatic fruits, initially there will be a declination in respiration rate. After some time from the harvest, the respiration rate increases and reaches a peak, which is called climatic peak. after that it decreases. So the post-climatic decline phase, it indicates the spoilage of commodity, whereas the active increase in the respiration rate shows the ripening and other associated changes. So these are the graph which shows difference in between different commodities. So avocado, you can see the intensity of respiration is very high. That means it's high respiring commodity, whereas banana, moderate respiring commodities. Fruits such as apple shows a very low respiration rate when compared to avocado and banana. So the climatic respiration during ripening of tomato. So you can see the respiration with respect to a milligram of CO2 per kg per hour, and with respect to days. So initially from you can see the associated color changes with respect to increasing the respiration rate of the commodity. So in case of tomato as well as in case of banana, when the respiration rate increases, it makes some changes in the color and other metabolic activities. So these are some of the changes associated with respiration of commodity. And other metabolic changes associated with increase in respiration rate. You can see after respiration, after harvest, the respiration rate increases. Here, the respiration rate is given as ml of CO2 produced per kg per hour of tomato. So it means that the respiration rate increases, and as the respiration rate increases, ethylene synthesis of ethylene will also get increased. And the changes in starch and soluble solid concentrations, the soluble solid concentration get reduces as there is a changes from complex sugar to simple sugar. The lycopene pigment get increases from the time of harvest. Similarly, the chlorophyll degradation will also be there, and the firmness. So if you see the polyglyconic activities as well as the firmness decreases and the polyglyconic activities increases. And pH, you can see the increase in titratable acidity until it reaches a climatic peak, and there is a reduction in titratable acidity when it reaches the climatic peak. So these are some of the biochemical changes associated with increase in respiration rate. So the water loss. So water loss is the major criteria we have to look into when you are discussing about cold chain of commodity. So maintaining under low temperature storage, low temperature transportations will reduce the water loss. So the water loss will give us direct weight loss. So which means there will be a direct reduction in the weight loss, which leads to reduction in the price. The losses in appearance. As the transportation increases, the moisture losses increases, the product shrinks, and it loses its marketability. The losses in textural quality, the crispiness and softness, firmness of the commodities is reducing when water losses is more. So this is the example for water losses in case of apple and peach. So when you are wax coating the commodity, water losses can be reduced, or when you are maintaining the cold chain with proper relative humidity and low temperature, the water losses can be minimized. So ways to reduce water losses after harvest is, the first is low temperature storage. So as we are reducing the storage temperature, metabolic activity get reduced, ethylene production will get reduced. So one of the major reason for weight loss and water loss is metabolic activity happening within the fruit materials. So as we are lowering the temperature, the metabolic activity get reduced. It leads to reducing the water loss. And high humidity storage. So when the relative humidity is maintained at a high percentage of 85 to 95%, it reduces water loss through transpiration, and it prevents surface injury. When there is a mechanical damage or when there is a physical injury, it enhances the metabolic activity, and thereby it increases the water loss. So when there is a impact, or when there is a bruising in the surface of fruits and vegetables, it increases the water loss. So thereby by reducing the impact damage, or increasing the harvesting methodology or improving the harvesting methodology will also help us to reduce the water loss. Application of wax or application of plastic lining over the fruits and vegetables during transportation and storage will also helps us in reducing the water loss. So this is one of the best example where you can see the water losses in pomegranate is reduced when it is lined with a plastic bag. So this plastic bag prevents the water losses. When it is as such stored in cotton boxes, the water loss and weight loss will be more. So this is the effect of waxing and sealing in case of orange. So the control sample, which is stored as such, shows more water loss, more weight loss, and then when compared to the wax coated and plastic bag lined oranges. So in case of control samples, the weight loss is almost 18%, whereas in case of sealed plastic bag lined or commodity sealed under plastic bag shows less weight loss of 2%, less than 2%, whereas wax coated has shown some less percentage of weight loss when compared to control samples. So physical damages such as surface injury, bruising, or this vibrational damages contributes towards water loss, and this damages causes browning of surface browning. So due to leakage of phenolic components, surface browning and bruising occurs, and it accelerates water loss. Surface damages accelerate water loss, and it stimulates ethylene production. As the impact site or a bruising site act as the it paves a ways to pathogenic invasion, and microbial losses will also be high in case of commodity which undergo physical damage. So this is the example of bruising of apple. So impact bruising or compression bruising of vibrational impact over the fruits and vegetable surface will also leads to increase in respiration rate and increase in ethylene production, and it also paves a way to microbial losses. So bruising of skin in case of banana and guava. So this is due to vibration or continuous contact with other fruit surface. Skin abscession in case of banana is very common when it is transported for a longer distance. So physiological disorders which causes due to improper storages, improper cold chain, such as chilling injury, freezing injury, heat damage, low humidity damage, low CO2 injury, and high CO2 injuries. So when these conditions, cold chain conditions, are temperature, relative humidity, as well as the gas compositions, if it is not properly maintained, it leads to some physiological disorder in case of fruits and vegetables when it is especially stored for a longer period of time. So this chilling injury is very common in case of tropical and subtropical fruits, which are sensitive to low temperature below 15 degrees Celsius. So most common symptoms of chilling injuries is browning, internal browning, as well as surface browning, pitting, water-soaked areas, uneven ripening, or failure to ripen. So in case of banana, it is very common. If it is stored under very low temperature, it fails to ripen. So most probably you would have come across certain situations where the banana failed to ripen in winter. So that is due to low temperature. So these are some of the commodities which are tolerant to low temperature or chilling injuries, some of the commodities which are sensitive to chilling injuries. So most of the tropical fruits and vegetables, which are grown under high temperatures, are very sensitive to low temperature, whereas the commodities which are grown in hilly region or high altitude regions are tolerant to chilling injury. So this is an example for chilling injury in case of citrus fruit and avocado. So the surface turned brown due to leakage of phenolic components, and the internal browning in case of avocado is due to low temperature storage. And chilling injury in case of yam and mango So as it is very common in case of tuber crop as well as in tropical commodities, where in mango, if it is stored under very low temperature, you can see a skin obsession like this. Banana, when it is stored under very low temperature or in cold storage, it leads to internal browning. It is very common when you are keeping the banana in refrigerator for 1 or 2 days, you can see this kind of internal browning, which is chilling injury. In case of pineapple and guava, the chilling injuries, the internal core of pineapple get turned brown due to chilling injury, and the surface browning of guava is very common when it is stored under low temperature. Freezing injury in case of orange. So when it is stored under below freezing temperature, it leads to immediate collapse of tissues inside the component. In the orange, it leads to production of huge loss of water, and you can see a fibrous internal core in case of orange. Heat injuries caused when it is exposed to direct sun or when it is exposed to high temperature. So when there is a thermal shock, or when you are bringing the orange immediately from the cold storage to a high temperature, this kind of heat injuries is very common. So heat injuries leads to some pitting in case of orange. So this immediate exposure to sunlight or immediate exposure to high temperatures causes bleaching, surface burning, or uneven ripening and softening in case of tropical fruits. Low temperature, low humidity, and when it is stored under low humidity conditions, it enhances disorders related to desiccation and senescence. So this kind of surface burning is very common when it is stored under very low humidity. And pathological breakdown, that's this microbial decomposition of fruits and vegetables. One of the most obvious symptoms when it is deteriorated under pathogenic microorganisms. You can see some of the examples of microbial decay in case of fruits and vegetables, Phytophthora infestation in case of pear, Penicillium expansum in case of peach, and in oranges, Alternaria. So these are some of the example for microbial decay in case of fruits and vegetables, which is stored under cold storage. And the effect of temperature and related humidity. As I said in the beginning, effect of temperature and related humidity play a major role in maintaining the quality of fruits and vegetables throughout the cold chain. In general, when there is an increase in temperature, when there is a 10-degree increase in temperature, the product, the changes will be increased to twofold. Or in general, you can say when you are reducing the temperature by 10 degrees Celsius, we can double the shelf life of perishable commodities. So most of the commodities, when the temperature decreases 10 degrees Celsius, the shelf life extends twice. When the temperature is increased from 0 degrees Celsius, for example, if the optimum storage condition is 0 degrees Celsius, when the temperature is raised instead of 0 to 10 degrees Celsius, it reduces 1/3 or 1/2 of the shelf life. And relative humidity is also playing a major role in maintaining the shelf life of the commodities. If the humidity is maintained around 95% relative humidity, it increases the shelf life. You can see when the commodity is stored under 0 degrees Celsius and 100% relative humidity, per day loss will be 1%. Similarly, when the relative humidity is decreasing to 30 to 50, 33 degrees Celsius, 33% to 50%, and the total temperature increase to 10 degrees Celsius, the losses will be 2 to 3% per day. And similarly, in the same case, when the temperature increase to 40 degrees Celsius, relative humidity when decreases to 4 to 5%, per day losses will be 20 to 25%. So these are some of the research results which shows the importance of temperatures and relative humidity inside during the cold storage or transportation. So in case of peaches, 3 different cultivars of peach, when it is the vapor pressure deficit, when the vapor pressure deficit increases, you can see the mass loss increases in different cultivars. And similarly, in the second graph, you can see the storage life decreases with increase in temperature, storage temperature. So under 5 degrees Celsius, Brussels sprouts have um, 70 or 60 days shelf life. So when it is changes to 5 degrees Celsius, there is a sudden decrease in the storage life. In case of lettuce, the storage life increases until 5 degrees Celsius. Beyond 5 degrees Celsius, the storage temperature of lettuce, the storage life of lettuce drastically reduced to 10 days or even lesser than that. And in the final graph, you can see the marketability of strawberry with respect to delay in cooling hours and firmness, shear force. And you can see the raspberries. You can see the raspberries, the marketability is getting reduced and the firmness is getting reduced when there is a delay in cooling. So when it is immediately when it is immediately cooled within 1 or 2 hours of harvest, you can see it maintains the firmness as well as the marketability. And in case of asparagus, the shear force increases, which is when there is an increase in shear force, the crispiness of the asparagus gets reduced. So and the marketability reduces in case of strawberry from when there is a delay in cooling. When it is immediately cooled within 1 or 2 hours, the marketability is high. And if there is a delay in cooling, like 4 hours or 8 hours, the marketability is drastically reduced. So this is the importance of temperature and relative humidity in maintaining the quality of commodity, and the effect of cold storage on weight loss of pomegranate. So in a study where they stored pomegranate in corrugated boxes and kept at the cold storage of 7 degrees Celsius and 95% relative humidity, and they can they have estimated the weight loss after 30 days, 22 days and 30 days. The weight loss is less when as it is stored under 95% relative humidity and 7 degrees Celsius. During the 22nd day, there was only 2.63% of weight loss, whereas in 30th day, when it is stored under 77 degrees Celsius and 95% relative humidity, the weight loss is 7.59%. Right. So these are some of the interesting results which shows the effect of temperature and relative humidity in case of cold chain. So similarly, the pomegranate, when it is stored under low humidity, it leads to a lot of weight loss and shrinkage of commodities. So the fresh samples, you can see the fresh samples, the aerials are sound, and if it is stored for a long period of time under low humidity, there will be a weight loss. Effect of dry fog humidification on pericarp browning of lychee. So once this is an interesting result which shows higher shelf life or higher shelf life of lychee when it is stored under 4 degrees Celsius with 95% dry humidification. So they have a control sample where it is stored under 4 degrees Celsius and 70% relative humidity, and another batch of lychee which is stored under 95% relative humidity and 4 degrees Celsius. The results, the control samples which is stored under 70% relative humidity under 4 degrees Celsius shows more surface browning after 20 days of storage, whereas the samples which is stored under 95% humidity shows retains the color. So this is the importance of relative humidities during the storage of lychee. So one of the important aspects to be taken into account when you are storing the lychees for a longer period of time is relative humidity. And as you are using dry fog humidification, so dry fog humidification is nothing the atomizer system which can produce small droplets of dry cloud or dry moisture. So it doesn't condense over the commodity, or the water doesn't get deposited over the surface of the fruits. So as it doesn't deposit over the surface, it increases the microbial quality, as well as it increases the relative humidity to 95%. So this is the best way to increase the shelf life of lychee. So you know that shelf life of lychee is very less when it is stored under ambient condition, and it's a highly perishable commodity. So there are a lot of farmers which are those who are not able to transport the commodities because of less cold storage facilities or less cold chain facilities. So lychee is one of the commodity where we can get only for a shorter period of time in a year. So when you have a sufficient cold chain technology to enhance the shelf life of lychee, it will be very much beneficial for the farmers. And the browning is due to changes in the surface character of lychee. The moisture is an important parameter for maintaining the cell structure in case of lychees. The weight loss and relative humidity was high in control samples, whereas the weight loss is less when compared to control samples in case of commodities which is stored under high humidity. So this graph shows the storage time as well as weight loss. So weight loss is high in case of control sample where it is stored under 70% relative humidity. When the storage related humidity is increased to 95%, the weight loss is very much reduced. There is a drastic reduction in the weight loss. So the marketability and the color, surface color is enhanced when the relative humidity is maintained. And important of pre-cooling treatment on respiration rate of grapes. So in a study where the respiration rate is drastically reduced right from the beginning, you can see when it is immediately cooled after harvest. When the grapes are immediately cooled, the blue color line indicates commodity which is immediately cooled after harvest, and the green color represents the commodities, the control, where it is maintained under ambient condition. So there is a significant difference in between these two respiration rate. So when it is immediately cooled after harvest or within 1 hour, of harvest, the respiration rate is very much reduced. Only it is around 30 milligram of CO2 per kg per hour, whereas in control sample, it is immediately increasing to 100 milligram of CO2 per kg per hour. So this reduction in respiration rate is possible only by reducing the temperature of the commodities immediately after harvest. So even the sample which is harvested, which is pre-cooled after 4 hours from the 12 hours from the harvest, you can see the respiration rate is almost 70 milligrams of CO2 per kg per hour. And the commodities which is immediately cooled remains under the low respiration rate. That means the commodity which is under low respiration rate, the biochemical changes will be minimum, the ethylene production will be minimum. So the chance of extending the shelf life is high when it is immediately cooled after harvest. So this is the comparison of grapes after 40 days of storage. So the first picture T1 indicates commodities which is immediately pre-cooled or immediately cooled after harvest, whereas the T5, which represents an ambient control sample. So you can see a significant difference in these two cases. So one of the important problem in case of storage of grapes or maintaining the cold storage of grapes is this browning in vein. So the vein browning or the browning of this vein is more when it is stored under ambient condition, and it is very less when it is immediately cooled. So this is one of the important aspects we have to look into when you are talking about the marketability of grapes. And the physiological weight loss is very much minimum in case of immediately cooled samples, whereas the commodities which is cooled after 12 hours, you can see the T4 represents the commodities which is cooled after 12 hours. Even within these two things, we can see a significant difference. Immediately cooled grapes remains fresh after 40 days of storage. And the firmness value is also high in case of immediately cooled, whereas cooled after the commodity which is cooled after 12 hours of harvesting shows vein discoloration, browning in vein. And similarly, the respiration rate of lettuce in case of immediately cooled samples, pre-cooled samples, shows low respiration rate and continues to be in the low respiration, under low respiration state for a longer period of time, whereas the control samples get spoiled immediately after 1 week of storage. So the respiration rate was minimum in all pre-cooled samples, and it was very high in case of ambient conditions. And the biochemical changes with respect to increasing the temperature is more in case of non-pre-cooled samples, whereas the pre-cooled samples, the respiration rate and the other metabolic activities are less. So this is a picture which shows the difference between immediately cooled sample and ambient samples. So the immediately cooled lettuce shows less weight loss, and it remains fresh after 20 days of storage, whereas the samples which is stored under ambient conditions without any cooling completely spoiled, whereas the commodities which is cooled after 12 hours of storage, 12 hours of ambient storage shows more spoilage when compared to immediately cooled samples. The first samples represents commodity which is immediately cooled after harvest, and the T5 represents control samples. T4 shows commodity cooled after 2 hours. So the thing is, the inference from this study is, as much as possible, the commodity has to be brought into cold chain after harvest. So if there is a delay, even a 12 hours of delay in bringing the commodity into the cold chest will have a drastic changes in case of storage. So these are some of the, in this table represents some of the commodities with its minimum safe temperature. Guava 4 degrees Celsius, whereas papaya 7 degrees Celsius, and associated chilling injury symptoms with respect to different commodities. Now come to the cold chain gadgets. So we have discussed more about physiological changes and effect of temperature and effect of time, temperature, and relative humidity during the cold chain of commodities. So the cold chain gadgets. So there are different cold chain gadgets associated with the different stages of commodity. So immediately after harvest, there should be some pre-cooling facilities, and during transportation, we need gadgets such as refrigerated trucks, refrigerated insulated containers. Whereas in case of retailing segments, we need refrigerators, reach-in coolers, display case, refrigerated display cage, refrigerated vending machines. So these are some of the gadgets which are very much important in case to maintain that continuous low temperature right from the harvest till it reaches the consumers. And these are visibility coolers, glass top freezers, cold display cabinets, or open cabinet with refrigeration facilities are available to display the commodity and for easy reach of consumers in hypermarkets. So this is another interesting component of cold chain. Cold bolt is a mechanism or is a device which aids us to use domestic air conditioning system to be used as a temperature reducing in case of cold chambers or walk-in cold chambers or mobile cooling units. So this cold bolt in one study, in a case study, the cold chain, this cold bolt enhances the keeping quality of onions, and it reduces the losses from 30% to 5%, and it get better price for the farmers. So just by doing some modification in the domestic air conditioners, it can be used as a cooling device for long-term storage or long-time transportation of commodities. So this cold chain, this cold bolt component, it makes some alteration in the circuit, and it prevents it helps us in continuous running of refrigeration and refrigeration system, and it reduces the temperature below 15 degrees Celsius or 10 degrees Celsius, depends upon our need. And these are some of the refrigerated refilled containers and refrigerated vehicles, which are widely used in case of cold chain, maintaining the cold chain during transportation. And Diacetyl, this is another invention which comes in plug-in type, plug-in chilling mechanism. So when the vehicle is at rest, when it has electricity access, it can be plugged to electricity, and it reduces the temperature of thermofluids, which is insulated through the panels. So the panels are insulated with thermofluids, where the temperature of the thermofluids can be reduced when during the night time, or when the vehicle is under when the vehicle has some access to electricity. And during transportation, there is no need of operating the refrigeration system. The thermofluids holds the temperature inside the container under low temperature. So by this kind of mechanism will helps us to reduce the operation cost by 60%, and so it can be used to for transportation, more 5 to 8 hours of transportation under reduced temperature, and it gives us access. It gives us low temperature storage for a longer time of transportation. This is also one of the important component in case this is a low cost technology for refrigerated transportation. And some of the new technologies which are available for maintaining the cold chain technology, which are warehouse management system, IoT or Internet of Things, and blockchain technologies for maintaining the cold chain, and food traceability system, and thermochromic ink, and photocatalytic equipments, modified atmospheric packaging, organic packing, dynamic ranking of commodities in the cold storage, portable sea tent, multimodal transport, PLC automation of cold storages and other storage facilities, adapting alternative cooling systems such as vapor absorption and thermal bank, and various hybrid application of energy, such as hybrid of solar energy as well as electricity, will help us to maintain cold chains wherever we have a missing links in the cold chain. So this IoT and blockchain technologies are some of the new concepts which helps us to enhance the cold chain management. So the use of IoT and cold chain logistic operations can help us to have complete control over the logistics, and to ensure continuous monitoring of quality changes during the transportation, during the storage. So it helps us to overcome some of the major challenges such as which are currently faced in the cold chain logistics. This IoT and blockchain technologies allows us to monitor real-time data, to gather in real-time data, and also it helps us to make some corrective actions during the course of transportation and storage. So this is a typical example how demonstrates how this IoT and blockchain technology helps us in maintaining the cold chain. So right from the harvesting, the wireless sensors, which is enabled to transfer the data to a cloud storage, will help us to locate the commodity and to steady the temperature, relative humidity of the commodity during transportation, during distribution centers, and when it is marketed in the supermarkets. So there are different technologies which are used: wireless sensors, GPS sensors, and RFID tag, barcode sensors, and proximity sensors. So these are some of the sensors which helps us to track the storage temperature, storage conditions throughout the cold chain. And it transfers the data to cloud space whenever it is needed. It can be easily accessed by the consumers as well as the retailers and the traders. And it is easy for us to make some corrective actions. If there is any changes in the temperature, we can either switch on some refrigeration component, or we can adapt some other methodologies to correct the temperature changes during the course of cold chain. So temperature monitoring and controlling. So this IoT technology and blockchain technology allows us to make some corrective actions. It allows us to continuously monitor the temperature during rail transportation or air cargo. It can be continuously monitored and some of the IoT enabled Acutas can automatically adjust the temperature of cold storage facilities and containers when it is transported for a longer period of time. So these IoT solutions also require minimum human interventions, so which reduces a lot of labors, and so that the cost of maintaining the cold chain is drastically reduced with the help of IoT systems. And it allows another advantage, shipment tracking, as we are enabling with some IoT sensors. It can enable us to monitor 24/7 where is the shipment, where, and what is the condition of the shipment. So other advantages are reduction in operational cost to maintain the storage, and reduces spoilage. So as there is an automated tracking and automated adjustment of temperatures is possible during IoT and blockchain technology, it can control and make changes in the temperature during storage. So as we are making this a real-time monitoring and real-time changes in the temperature, changes in the storage conditions, even gas composition can be changed or altered during using these IoT technologies. So these are some of the important aspects of using IoT and blockchain technologies. So real-time data access, automated report, these are some of the benefits of using IoT and blockchain technology. So blockchain technology, each and every stages of operations, right from the harvest. So farmers will give some data, where it is produced, what is the condition of commodity, what is the condition adapted during cultivation. So that information will be encrypted, and other processing during pack houses, some information such as what are the processing operations it underwent, and distributor will give what is the transportation condition, what is the temperature maintained under such conditions. So this information can be readily accessed at any point of time by the consumers or the retailers, which helps us to, it gives a reliable data. So this is a in Finland, they are using blockchain technology to show the journey of milks to the consumers. So the consumer can access the data right from the farmers, producer, distributors, and retailers. So what is the condition of temperature? What is the storage condition? So based on this, we'll get a reliable data, and the consumer will get reliability from the cold chain blockchain technology. The holistic collection of data such as storage, analytics data, processing data, and transportation data, temperatures, relative humidity, gas composition data, it will be convenient enough for the consumers to select the product which is more reliable. So there are different companies which provide this IoT solutions, IoT and blockchain softwares. So these are some of the advantages of using IoT technology, IoT and blockchain technology: transparency, damp-proof data monitoring system, cost efficient, and some of the limitations of using this IoTs: linking with physical flow, platform choice, and computing power. This technologies, IoT and blockchain technology, are in the early development stages. So still there are a lot of improvements needed to adapt these technologies. So this is one of the company, which provide farm to fork solutions in monitoring the changes throughout from the field until it reaches the consumers. So during cold chain tracking, traceability until it reaches the consumers. And e-traceability is one of the component of using blockchain technology, right from harvest, what are the changes it underwent, what are the processing until it reaches the consumer can be readily available for the consumers. So Source Trace is one of the company which provides the software related to tracking and monitoring of conditions of commodity. So the entire concept is remote cold supply chain management. Sensors and Acutas can provide data collection, and data collection can be stored in cloud storage. Wherever it is needed, it can be accessed. So Emerson and Zenmate, these are some of the popular companies which are providing software solutions and sensor solutions. Emerson sensors are very much popular in case of maintaining the cold chain temperature and making corrections in the cold chain temperatures. So that's all from my side. Participants, if there is any queries, you can ask.
Thank you, sir, for your informative lectures. I'd like to request all the participants to raise your hand or drop questions on the chat box.
Participants?
Okay. There are some questions. Yeah. I am reading these questions. Are the blast chillers are considered as pre-cooling system? Sir, please answer this.
Yeah, blast chillers are basically forced air cooling system. The application of blast chillers are more in case of freezing. So it is used as a freezing system. The forced air cooling system is similar to that of blast freezers. The only difference is the temperature. So if you can able to reduce the temperature instead of -18 degrees Celsius, which is used in case of freezers, to temperature such as 2 degrees Celsius or 1 degree Celsius, it can be used as a pre-cooling system.
Thank you, sir. Another question is there any chances of cold burn when fruit and vegetable are refrigerated?
Most of the tropical commodities, when it is refrigerated, gets a chilling injury. For example, most of the tuber crops, when it is stored under refrigerator, or banana, when it is stored under refrigerator, there are chances of chilling injury.
Dr. Prasad, you are muted.
Yeah, thank you. So definitely there will be nutritional loss when it is in case of chilling injury. So once it is underwent a chilling injury, it cannot be consumed or it cannot be marketed.
Hello, sir. This is Siddhartha.
Yes.
Actually, in the last year, I have worked to start an organization to supply vegetables and fruits from the farm to fork in a cold storage setup.
Yeah.
But the problems I faced are, and I had to set up different cold storage setups for different vegetables and fruits. So it became very cost effective. Is there any solution for this to set up everything in a single storage?
Yeah.
Maybe inefficient. Of course, number of days that we can store, it will decrease definitely, but 2 to 3 days of storage is fine for my requirement.
Yeah.
Also regarding, sorry?
There is a concept, multi-commodity storage facilities are available, but it cannot be accommodated with wide range of commodities. For example, we can store the optimum commodities which have optimum storage of 10 degrees Celsius to 20 degrees Celsius. But we cannot store the commodity which requires 0 degrees Celsius or 2 degrees Celsius. For example, apples cannot be accommodated with tropical commodity.
Okay.
So still,
maybe we can set up at least 2 or 3 cold storage for set up everything. It works for all vegetables and fruits, right?
Yeah.
Yes,
instead of going for a larger cold storage facility, if it is possible for you to make two different cold storages where it can be operated from 2 to 5 degrees Celsius or 2 to 7 degrees Celsius or 10 to 20 degrees Celsius. So most of the commodities can be accommodated in that
10
range.
to 12 and 2 to 7.
Yeah. 10 to 20 degrees Celsius where most of the tropical commodity can be accommodated, and 2 to 10 degrees Celsius or 2 to 7 degrees Celsius in most case, we can accommodate a lot of commodities where the storage temperature is 2, for example, apples and other high attitude commodities.
For these two, humidity is fine, same for.
Yeah, humidity is mostly the humidity from 85% to 95% will work for all the commodities.
Okay. Sir, about pre-cooling, can you, I mean, I'm not clear about the pre-cooling, sir, and I mean, what to do at the time of after post-harvesting, if we just shelter it in a cool place, is it fine, or do we need compulsorily, do we need some fans or something?
Yeah, if it is possible to enhance the cooling rate, or if it is possible to enhance the rate of cooling, that will be very good to maintain the quality throughout the cold chain. Actually, farm level cold storages are very much pre-cooling operations are very less.
Yes.
As much as possible, without any time delay, with maximum within 4 hours of harvest, if it is reaching a cold storage facilities, that is well and good.
Okay, thanks.
Thank you.
Thank you, sir. Another question is from Renu. Among hydrocooling systems, which is the best technique for cooling for fruits, either forced air cooling or evaporative air cooling?
Actually, it depends upon commodity. For example, leafy vegetables, we cannot use hydrocooling system. For food material, fruits and vegetables such as carrot, apple, so it can be pre-cooled using hydrocooling system. And leafy vegetables, mushrooms, and other commodities, it cannot be used under hydrocooling technique. It completely depends upon the commodity.
Thank you, sir. It was a nice informative session, and we are going to finish our question answer session. Next, I would like to invite Dr. Gokarneshwar Sahu, who is working as an assistant professor from Department of Chemistry, National Institute of Technology, Rourkela. He has graduated and post-graduated in chemistry with advanced organic chemistry. He has done PhD from Organic Chemistry Division, National Chemical Laboratory, Pune. He has more than 20 years of teaching and research experience. About 5 PhD research scholars and more than 9 master's students have been guided under him. He has published 10 research articles so far in international journals and 8 presentations in conferences. His expertise lies in organocatalysis, natural product synthesis, and mechanistic interpretation. Thank you, sir, for being here. I would like to deliver your lecture about analytical techniques for molecular characterization in food engineering research. Now, over to you, sir.
Thank you.
Thank you, sir.
I hope the slides are visible.
Yes, it is visible. You can start now, sir.
Okay. So first, I would like to thank the organizers for inviting me to give a talk. Of course, it will be a little bit different from what we are hearing since 4 days. I'll give a different taste to the talks what we have been hearing. And especially I would like to thank Professor Ram Pradhan and Professor Arun for their kind invitation. I was in fact very excited because I will not be talking very detailed chemistry, but how chemistry is applied in different fields. So without wasting much time, I would like to go to the presentation now. So here what we see that I'll be talking about analytical techniques for molecular characterization. Yes. So analytical techniques for molecular characterization in food engineering research. Before I move, of course, I would like to acknowledge the agencies, the institute, which is helping me during my research career, during my, the running of my research group. So these are the funding agencies. We have recently got some monetary help. So it is DST, New Delhi and DST Odisha. Of course, NIT Rourkela is highly acknowledged for all the infrastructure it has provided. Then going to the people, of course, we have a research group here. I have the PhD scholars, and especially for this presentation, Mr. Jitendra Panda and Ms. Sandhyarani Mishra, they have helped me a lot. Of course, during the talk, they will be presenting their part in this presentation. So before going to, how can I take this top part out? Yes, I think that is fine. Yeah, probably this is okay. Okay, so now before going to some chemistry, I would like to link food and chemistry. And you can see, of course, we have heard about, processing of food, and what are the ways to conserve food, what are the ways to storage food. But then the main factor which is responsible for a material to be called a food are these chemicals. You can see I'll be going through different foods, and then the chemicals involved or chemicals it contains, which is responsible for its color, for its taste, for its fragrance, and other things. So I'll just be going through different chemicals which are the contents of different foods. So here you can see vanillin. Of course, we know we know where it is used. We have a flavor of vanillin in ice cream and other things. And this is particularly this compound which is called vanillin. And you can see in 1870, in 19th century already, this key flavor of vanilla was one of the first flavor compounds to be synthesized in a lab. Because again, to bring you a little bit about chemistry, these compounds, of course, are available in nature, in foods, in plants, and other things. But now the problem is, when the need increases, we cannot get enough of this chemical to be supplied to all human beings. So that time, these organic chemists, especially like us, the synthetic organic chemists, they try to synthesize in a laboratory. Because when you can synthesize this compound, you can have it plenty. How much you need, you can build it yourself and then use as food. So you can see this was synthesized in 1870. Then there is another one which is having the butter flavor. This is called diacetyl. Of course, I hope you can have little understanding about the structures, but not necessarily you need to pay attention here. But this is a chemical structure, organic molecule, which is responsible for the butter flavor. And you can see it was produced artificially in a laboratory in 1920. So when you can synthesize this, you can have it as you want. Then coming to this compound, methyl anthranilate, you can see this was also synthesized in early 1900. Just a minute, it is having some issue here. Okay. Yes. So there is, you can see here how it was synthesized. So there is biosynthesis. I would like to talk about this biosynthesis. It means that it is synthesized, but not by human, but in a bioprocess, by enzymes. And you can see this glucose. This is a very well-known carbohydrate, which is there in every house. It is part of the sugar we used to take. So this is heavily available, glucose, I think in everywhere. But that, you see, it can be converted to the vanillin, what we need as a flavor. And then another one is, there is, of course, another process, the biotransformation. Again, this is by enzymatic process. So the researchers, the scientists, they have characterized the enzyme which can transform this compound to the very required vanillin. Then let's talk about coffee. And we know, I hope if all these attendees, they have a nice lunch, they must be falling asleep. But now this is something which can keep us alert. We all know. But what is responsible for that coffee is this caffeine, this organic molecule. This is responsible for, which influence the central nervous system, so which activates the central nervous system so that we stay awake, we don't fall asleep. So now let's talk about little more detail. And here is something, of course, during this talk, you will see my co-presenters, they will be giving you some processes. They will demonstrate how this thing is done. So you can see something is solvent decaffeination, because coffee is good, but sometimes too much of coffee can bring or can lead to sleepless nights. So what is normally done, that these coffee seeds, they can be little bit decaffeinated. That means some of the caffeine content is removed from the caffeine seeds, and this is done by this process. You can see a solvent. Again, it will be presented in very detail, but some organic solvent is used. If I take you back here, you see this is an organic molecule, and if you use one organic solvent, then what it does, the organic solvent dissolves this caffeine, so it reduces the content or the percentage of the caffeine in the seeds. And then when you process it, you will have a coffee with less percentage of caffeine. There are other procedures you can see. Of course, the caffeine is there to activate your nervous system, but then there are some other chemicals which are responsible to give that flavor. I hope all of you likes the fragrance of coffee. But when it is done, then what happens, that those fragrance molecules or molecules responsible for the fragrance of coffee, that also gets washed out. But now you can see there is a process, you can get rid of it. So you have organic solvent, you have water. So when you do this, you get the caffeine out. But then the water, when these fragrance molecules, they will be coming in the water, and you can restore that back into the seeds. So you will have the fragrance of coffee along with less percentage of caffeine. So here there is another process used, different industries, different ways to get different percentage of caffeine. I hope you must be knowing about this coffee powders with different percentage of caffeines. Okay, so then let's go to something, of course, we do see every day, the brinjal. You see there is a big compound, a big organic molecule, which is responsible for this color here. And one normal practice, if you have ever gone to your kitchen, if you have helped someone, or if you have done by yourself, if you have got the brinjal, at some point you see the brown color things appear. Why this is so? Because you can see this phenolic compound, this is of course one organic molecule, and you can see here they are there, that with long standing gets oxidized to this compound, which is having a complex brown polymer, and that gives that brown color. You can see it turns little bit like this. So that is because of the change in this. Now about spinach, of course we know, when you have less iron content, the doctors advise you that you take spinach. But then there is a problem. What is that problem? Is of course it has lots of iron. You can see 2.6 milligram per 100 gram. But now the problem is only it is absorbed 0.044 milligram per 100 gram. So that means not all iron present in spinach will get into your body. Okay, so maybe you need to take more spinach to get your iron content or iron content compensated in your body. Now in comparison, you can see the sirloin stick. Here, of course, you can see similar amount of iron per 100 gram, but now here the iron which can absorb from this is more, because 20% can get absorbed. Now, why it is so? Of course, this organic chemists, they have found the solution because there is something, this compound, which is called oxalic acid. You don't need to know the name, but this compound binds the iron. This compound, just like here you can see, there is calcium, and this compound binds the iron. When it binds the iron, it doesn't release it to your body. Okay, so that is the you can think about a little bit negative point of spinach, but still then, there is a reason that, or at least the organic chemists, they do understand why the iron or all of this iron cannot get into our body from spinach. And then again, another thing, if you have realized that after eating spinach, you get this white teeth. That is because the oxalic acid reacts with calcium and your saliva to make calcium oxalate, which is a white crystalline powder-like structure, and it gets stuck to your teeth, and it gives you probably a brilliant look. So that is the the organic reaction going on when you eat spinach. Then about broccoli, of course, we know broccoli is a very good vegetable because it has anti-cancerous properties. Now you can see there is this chlorophyll, the structure here. Again, it is another organic molecule. And during this process, what happens? This gets decomposed to this compound here, which has anti-cancer property. Okay, so now you can see what happens. Normally, this organic chemist or in general chemists, what they do, or of course in collaboration with biologists, once they know a structure is responsible for some good properties, for here anti-cancer property, they can build this molecule. Okay, they can build this molecule as a drug, and you can have it plenty, or you can have it when you need. So you can see this molecule is having anti-cancer property. But then what happens? Many times you must have heard that people suggest that don't boil the food so much, because you can see if we boil the food, this compound gets decomposed, and when it gets decomposed, you don't get this compound which will be having a good activity like anti-cancer activity. So normally the broccolis are eaten by just half boiling, and then you eat it, so that you can have all these compounds stable in the food. Then it is about egg. You can see this, of course, the eggs we do here, we get a lot of whitish in color, but this people call it desi chicken. You can see here. So these are little bit the color is this, and that is because of this one here. This cell contains this, and you can see when you put these eggs under UV light, you will see some fluorescent nature, and that is just because of this molecule, which is having long conjugation. If you know about these pi bonds, they are in good conjugation, so that gives a fluorescence property to the egg cell. Now it is about mangoes. Of course, we all eat mangoes, and we see that they have different aroma. Different mangoes, they will smell differently, and that is because it has been seen that 270 plus volatile compounds detected in mangoes, because of course we have different varieties and there are different chemicals. Now they are volatile because when we get some smell, again, everything is chemistry, I would say. So if you smell something, that is definitely because of a molecule, and those molecules are volatile. Volatile means they have very low boiling point, so they get evaporated, evaporated at room temperature. So when you get evaporated, you see the smell. Okay, and then here one more thing. Of course, if you have taken this raw mango, sometimes your skin gets itching sensation, and then that is because of this phenolic compound. You can see this contact dermatitis. So that means these compounds, they are little bit sensitive to skin. Not to many people, but at least to some people they have this, because it has little bit poisonous nature, and you get that itching. Here again another thing also, we always hear about frying things. People should not eat frying things. That is because it has been found that this compound, this is called acrylamide, this is responsible for cancer. This is a very cancer-provoking organic molecule which can cause cancer. And then it has been found that if we fry the foods with high temperature, for example, these potatoes, then bread and other things, what happens there? The carbohydrate, you can see the carbohydrate-rich foods that reacts with amino acids, all are present in the food, and they react with each other to give acrylamide. Of course, then again, they say that, it is not well proven, but it has been proven in animals, not in human. I don't know, maybe it is just to protect the food industry, but then this is something, it is better to take precaution that we should not eat much fried foods, because that can lead to acrylamides, and which is, having cancerous properties. Then this one, turmeric, of course, we know very well, we use in everything. And again, the color is because of this curcumin. You can see there is yellow color, and that yellow color is because of this high conjugation of the molecule. And again, we already know that it has several positive effects to the human body. This is something about berries. You can see again different molecules having different properties, and it says that this compound is sweet in nature, this compound is sour in nature. So a berry will be sweet or sour depending on the percentage of this. And in many, they are both present, and in just different proportion. If this is more, it will be little bit sour taste, but if this is more, then it will be sweeter. Now again, of course, I remember Professor Arun was talking about this Finland. I was there in Finland, and when we go to pluck berries, we always are warned that careful of poisonous berries. And this is here, these poisonous berries is because of this HCN. If some berries, they do have this compound, that can lead to HCN, which is poisonous to body. So of course, the locals there, they know that which is good, which is bad, but you can see again, these organic molecules, they are responsible for everything. So now I'll come back to the role of an organic chemist, what they do. Now you can see here, I little bit bring your attention to all drops. This is one paracetamol, which, I think everybody takes when they feel sick. And then there is crocin. You can see the molecule inside it, and they are all synthesized by industry. Of course, caffeine we did talk about. Now, what we do synthesize these molecules according to need of human being. That is our job. Now, again, to the very top, what we'll be giving the characterization techniques. So in the process, of course, we'll be dealing with several processes which we do in the chemistry lab, and very particularly we'll be talking about these two equipment, which of course we have in NIT Rourkela. So this is one NMR spectroscopy, nuclear magnetic resonance spectroscopy. I'll tell that what we get, what kind of information we get from that. And then there is high resolution mass spectrometer. Just to tell you where it is housed, it is just housed next to the tea stall under the banyan tree. This is there. Of course, there is a name mentioned, NMR lab, and this one is there in the table. So we'll be, I'll be telling about the principle, and then the co-presenters, they will be talking about different processes. So let's go. Okay. So now let's go to the little bit the principle. I'll not go in very detail. But you can see what is applied in all these spectroscopic methods. So this is electromagnetic radiation. I think you all know that the electromagnetic radiation that varies with different frequencies or wavelengths over a time, over different ranges, and they have been named accordingly. We have gamma rays, X-rays, UV. Then of course you can see different colors here. That is because we do see that color, which is called visible electromagnetic radiation. Then we have IR, microwave. So there are different spectroscopic methods used for with or used at different wavelength of the electromagnetic radiation. And in that, you can see down here we have infrared IR spectrometer, we have UV spectrometer, we have microwaves and radio waves, of course, that is used for NMR techniques, and then we have X-ray. Okay. Cannot I hide this one?
Excuse me, sir.
Yes.
Hello?
Yes.
Yes, sir.
I think this is okay.
Okay, okay.
Yeah. So now I would like to tell a brief idea about different techniques and what do they do before we focus our attention on NMR and HRMS. So now you can see we have different regions of electromagnetic radiation, and I have just given 2 molecules. In fact, I have synthesized these molecules in my research career. So I'll just be talking that what do they give us. So when you have different compounds, as you saw in all foods, fruits, vegetables, and everything. So now you see what they do. If we have UV visible spectroscopy, from there we get these aromatic rings, conjugation, and substituent. So we get this kind of information about the molecule in UV visible spectroscopy. Then we have IR. Here what we get? We get the amide ester. For example, you can see the amide, CONS2, the ester, the olefin, hydroxyl. So all these functional groups, they can give or they can be observed from the IR spectrum of a compound. Then we have NMR spectroscopy. So here you can see complete characterization. That's why this NMR spectrometer is very essential when you want to characterize certain organic molecules. Then we have X-ray. Of course, in X-ray, what you get the complete picture of your molecule, but there is one a condition that your compound should be crystalline in nature. It should be solid and it should be crystalline solid. If you have amorphous solid, then you won't get any information from X-ray. And then finally, mass spectrometry. So these give the total mass of your compound. Of course, we will be discussing in due course. These points here, I will not discuss about it because it would be a little bit too much, because this is all about principle. But when we talk about the NMR spectrometers, maybe you will get some idea. So these are all principles. How do we get the NMR spectrum of a certain compound in the NMR spectrometer? So let's not go there, but yes. So this is what the spectrum of a molecule looks like. And I think all of you know about ethanol. Even if you are not an organic chemist, I know, because this is the very ingredient of all this alcohol beverages. So this is there, and you can see the spectrum of it. How does it look like? Of course, we have a demo. We have taken this NMR in the spectrometer. You will see in due course, and this is how it looks. So when we get these, we analyze according to the chemistry knowledge that yes, the compound what we have experimented in the NMR spectrometer, that is a molecule of ethanol. So we do see that. Then we have this is again different compounds here, and here this is all about carbon NMR. Okay, so so what happens here, you can see in any organic molecules, there are protons, this H, there are carbon. So there are different NMR techniques by which you can characterize the protons separately. You can characterize the carbon separately. So this is how you can see, the point here, why carbon NMR is important. In case, of course, I have done few NMRs for the students from food process engineering department, and they should know that which NMR is essential for characterization of their compound. So many times it is necessary to have proton NMR as well as carbon NMR for complete characterization of their molecule. Then you can again, we have 2D spectroscopy, because all these proton carbon, they are 1D spectrums or 1D spectroscopic methods, but then there are also 2D spectroscopic methods for characterization of these complex molecules. So this is all about, and again, in addition to proton and carbon, also it is possible to have NMR for fluorine. Of course, you guys know about the fluorine atom there, and it is possible to find or to know the environment of fluorine in the molecule, and by which you can characterize your compound. Similarly, the phosphorus atoms present in your molecule can also be detected by NMR spectrometer. Again, these are different techniques what we use in the spectrometer. These are different methods. Again, I will not go. Okay, so I'll be talking about a little bit about this. So this is the periodic table here, and we can see that what atoms can be analyzed by the NMR spectrometer. So there is proton, there is carbon, there is nitrogen. Of course, why they are NMR active, that is the principle I will not be talking about. But these compounds, they can be detected in the NMR spectrometer. So we have proton, we have carbon, we have nitrogen, we have fluorine, we have phosphorus, silicon, we have titanium, so we have vanadium, we have bromine. So these all atoms in a molecule will be characterized by this NMR spectroscopic method. So you can see how this method is so useful in the characterization of organic compounds. So these are different 2D. Again here, this is one very advanced, very recent topic or very recent use of NMR spectrometer. What is that? You can do the reaction in NMR. Again, you will be shown by Ms. Mishra today about how a reaction is executed in organic laboratory. But now something has happened that you can put a reaction in the NMR tube. That means when you put the reaction in NMR tube, everything you can characterize by the NMR spectrometer. So that is a very recent advanced technique, or very recent advanced use of the NMR spectrometer. So now I will request Ms. Sandharani Mishra to take over and present to you about how a NMR reaction is executed in an organic laboratory. Please.
Thank you, sir. Good afternoon, everyone. So now we will discuss how we are doing the stoichiometric analysis and the execution of a reaction in our laboratory. So coming to the reaction, here you can see that we have two molecules in the reactant side, the molecule A and B. We are taking it and make it soluble in toluene, and we have observed the reaction for 20 hours, and then after 20 hours we are getting a salt. And as we know that salts are polar in nature, so they are soluble in water. So it is none of your interest, but in chemistry we know that polar attracts polar. So as the salt is polar and water is also polar, so it will get solubilized in water. So then after that, still our compound is not formed and it is in the form of salt. So we are adding one base dropwise manner. So I will show you in a video that how the process is going on. So there you are able to know that what is going on or not. So I'm playing the video next. So guys, sorry for the interruption. So here is the video. I'm starting from the first. Initially, we are taking one separating funnel. We have various workup techniques, but here we are using the liquid extraction technique. So this is the separating funnel which I am taking, and I am adding the water soluble salt which I collected previously. Then after that, you can see. Okay. Okay, you can see that I'm just close the separating funnel using a stopcock and adding some water so that it will not stuck. Then I will just shake it and release the pressure from the smaller volume side so that it will not acquire any outer air inside it and make the pressure. So after some time, you will see, you can see that two layers are now separated. And now we are just collecting the lower part. So you can see that the separation here, the above layer is the toluene layer and the below is the salt which is dissolved in water. So now I also collected the organic layer which is the toluene separately. You can see here I'm adding the base and it is formed one residue which is a white precipitate. After that, once the precipitation is over, I will just filter it using one sintering funnel and make it solubilize in DCM and concentrate it. Okay. You can see that this is the filtration process we are following. Okay, so then I will just discuss how to put a reaction in our laboratory. Is there? Okay, you can see that this is the extraction reaction procedure which I have showed you one practical here, and this is the image. So here we are using the principle is the workup is based on the difference in the densities of the two liquid phases. The liquid phase which have higher density is come at the lower part of the separating funnel, and which has the lower density, it remains in the above one. Okay, now coming to the execution part of one reaction. So first, we are just calculating the stoichiometric ratio. You can see here in this table, I am taking in 1:1.2 equivalent of these two compounds. Okay, one is the 4-hydroxy 3-nitrobenzaldehyde, and the second one is the methyl E3 4-hydroxy 3-nitrophenyl acrylate to get this. So for this also, I will show you one video on practical session that how we are doing it. Okay guys, then you can see here, this is the fume hood where we are just doing a reaction. This is just shielded the. So about something about the fume hood is, it is our protection that it shielded the researchers from the devastated effect of the chemical spills, fires, and some unhazardous fumes which are coming out from during the reactions and from the unintended reactions. Okay. Okay, so from starting, I'm just going to start from how we just weighed the things we need. So this is our weighing machine. It is present in our lab. So using this, we have weighed the things. Okay, you can see that this is the measurements we are taking. This is our second compound we weighed. Okay. The coming to the next, how reaction we are putting. Okay, you can see the RB is placed over a magnetic stirrer, and funnel is there above it, so that easily we can put our compounds inside it, and there is no loss of our compound. And while putting our reaction, we are using gloves, aprons, and some safety glasses for our safety purpose. Okay, this is the nitrogen balloon we have attached with the RB, so that the RB round bottom flasks atmosphere should be inert, while so that no hazardous things will happen in future. This is the THF. These are the solvents we are used to make solubilize the compounds, so that two things, as we are taking two solid compounds, it will mix with each other, and the reaction will go in a very good manner. That's why we are using the solvents. Here we use THF, tetrahydrofuran, and DCM, that is dichloromethane, and this is a Wittig reaction. And here we are setting the RPM, rotation per minute, and this is the temperature. This is the room temperature showing here. You can see that the things are now rotating, and it is not completely, but slowly it is admissible down, and the solids are solubilized in the solvent slowly. Then after some time, we just added our second compound, which I have told you previously, and you can size inside the whatever we have previously. Okay, so this is the setup we have in our compound. And further, this reaction goes for 3 hours, and after that the reaction is monitored using TLC, and that session is going to be taken by Mr. Jitendra Panda, and he will explain the rest of the things to you.
Good afternoon, everyone. Am I audible?
Yes, sir, you are audible.
Okay. So now, as my colleague Ms. Sandhya has explained, like now how to put a reaction. So now in the reaction times, he has explained that the reaction was continued over 3 hours. But how we know whether a reaction will continue for a 3 hour or for a longer time, or it may complete in half an hour? So for that reason, we always do the reaction monitoring. So how we will be doing the reaction monitoring, that I will be explaining in this session. So for reaction monitoring, we are using a very simple organic technique that is called thin layer chromatography. So in thin layer chromatography, what we do, it is a technique to separate mixture into its components. Let's say in this reaction, what she has explained, there are two compounds, A and B she has added, and she has reacted that mixture for 3 hours. Now there are two components present in that reaction mixture. Now how do we know that the reaction, the components what it is present in the reaction mixture is completed or not? So to separate those components of the reaction mixture, we always take the thin layer chromatography. We always use the thin layer chromatography technique. What we use here, we use the mixture what we take, that is dissolved in a solvent. Let's say if that is now what we take the reaction mixture, that is that is the reaction mixture we are taking, and in that one we are also taking a a eluent, where the eluent will be the mobile phase and another will be stationary phase. What would be the stationary phase? The stationary phase will be, so if you see, this is the stationary phase. I will show the real-time TLC also. So this is the stationary phase, which will be a very thin layer silica plates. That's why it is called thin layer chromatography. So on this stationary phase, we will be explaining how we are doing the thin layer chromatography also. But a small idea I am giving. So we draw a baseline and we draw a solvent front. We put the reaction mixture and the let's say after some time, the reaction mixture and the starting materials. So then we run it in a mixture of solvent. Always the mixture of solvent we take, those are volatile organic solvent. So generally we take PET ether, ethyl acetate, DCM, chloroform, acetonitrile, or the TLCs. So after elution, if you see this graphical image, if you see here the black spot, there are three spots. One is black spot, one in between, another is the blue spot. The black spot what we take, that is the starting material. In this case, if you compare this Wittig reaction, it may be the product A, so the reactant A, and the blue spot is the reaction mixture, and the in-between spot what is present here, that is the co. Co means we take in this spot we take the reactant and the reaction mixture all at one spot. Why do we take co? We take co because so in some TLCs, we observe that the spots after elution, if you see here, they are quite different from each other, or they moved in the TLC quite differently. But we have experience in our reactions that some spots, they are very close to each other. In that case, we were not able to, or we will not able to know whether the reactant or the starting material has finished or it is completed or not. So for that reason, we take always co, so that if some spots, the reactant and the product, if they are very close to each other, from there we will get to know whether the reactant is completed or not. So now coming to a real-time TLC, this looks like this. Now, as we have taken the starting material, as I have told, the reactant A, then in the reaction mixture, what is running in the, or what is stirring in the RB, we have taken through a capillary and spot it on this at this RM spot, and co, where we have taken both starting material and the reaction mixture. Now we ran into a solution, into a eluent, where we have taken 50% ethyl acetate and petroleum ether. So in that eluent, when we run this TLC, so we observe that there is quite there is a quite different spots we observed, and they are very distinct, where we see that the starting material is not present in the. So afterwards, we can do stop the reaction, we can concentrate, we can do the workup, all we can do. This is a TLC, which is like, let's say this is UV active. After running the TLC, I will show the video. There I can show you, just have a look upon the TLCs. So this looks like how a thin layer chromatography is. So now coming to a principal part, so what happens? Initially, what is sample we take, we applied on the stationary phase as I have explained it. Now we run it. So now why these different spots at different position? This is because of the interaction of the molecule or the reactant with the silica. So which is polar, as I have shown here, this black spot, which is a polar spot, that what happens is strongly interact with the silica gel. Silica gel is nothing but it is silicon. So it interacted with SiO2. So it tightly bind with that silica and it runs very slowly. But where which is less polar spots, those would not able to bind with the silica. So they run little bit fastly. So they go up in the TLC. So to explain that, here if you see, if spots we will see in the top of the TLC, where if we have some more polar spot, we will be saw in the bottom of the TLC plate. Now coming to the mobile phase, as I have explained, the mobile phase is the solvent system or the TLC solvent we took. So it may be a mixture of solvent or a single solvent if you can take. If your reactant or the reaction mixture are very polar, you can you can take a very polar solvent. Let's say only ethyl acetate you can take. If that is a very non-polar, if your reactant and the reaction mixture are not very polar, they are very less polar, you can take only PET ether. By that also you can check the TLC. So here here you can take a single solution or a mixture of these solvents, petroleum ether, ethyl acetate, chloroform, all these to run the TLC. So it depends, as I told, the polarity, and we generally use volatile organic solvent because we will see in the UV, if the solvent will not evaporate, will not get the spots very clearly. So now how to calculate, like how to know this TLC, we can know from the RF value also. So the RF value we can calculate it, the distance traveled by the substance and distance traveled by the solvent from. That means in which solvent you are running, how much the solvent has run and how much the spot has run. So now in the initial, before elution, if you see, they are all at the bottom. The RF is equal to 0. When we do the elution, after running the TLC, the solvent reaches at this one, then we take out. So then we check that RF. So this has moved 1.5 centimeter from the bottom, and this blue spot has moved 2.1 centimeter from the bottom, and from this baseline to the solvent is 3 centimeters. So how we calculate the RF? For the blue spot we calculate it is 0.7, for the black spot we calculate it is 0.5. So now I saw, when I showed you the real-time TLC, there you can see there are two types of TLCs I have shown you. One is blue color, one was little bit pink color. That is due to different staining method we apply. So there are different staining method which we can apply to the TLC. That is, one we can do KMnO4 charring. You can show KMnO4 solution we take. So there what we do, we dip the TLC plate. What it does. So as we know, the KMnO4 is an oxidizing agent. It oxidizes some of the functional group if it is present in the compound, such as if there is olefin, there is some carbonyl groups. If this doesn't work, or if doesn't work, then we can also opt for iodine vapor, where we put the TLC in the iodine chamber, where the iodine and silica will be mixed, that it will form colored spot due to the complexation of these organic compound with the iodine. So then further, if we have used amino acid, we can use ninhydrin. If some nucleophilic property type groups are there, we can use also para-anisaldehyde solution. So now I will show the video how we can do the TLC. Now, if you see, I have taken a thin plate of TLC. If you look into it, it is a very thin plate. If you see earlier what happens, there was a slide, glass slide. Upon it, we put the slurry, silica slurry, then we dry it to make a TLC plate. But nowadays, it is very quite available. That commercially it is available. It is on the aluminum foil. It was the silica slurry they have prepared. So as you can see, I have taken 3 spots in the TLC plate: starting material, co and reaction mixture. Earlier I have edges, or I have cleaned the edges of the TLC plate for the smooth running of the solvent. So now what I will do, I am writing, or it is just to know which reaction is for which which TLC is for which reaction. Now you can see I have put I can place the spots on the starting material and co. Then you will observe I will take the reaction mixture. Now you can see I am taking the reaction mixture. Then now I have put it in reaction mixture spot and the co spot. Now what will I do? I have taken the solution. What is I have made 50% ethyl acetate and PET ether. Now I will run the TLC with 50% ethyl acetate and PET ether mixture. So the solvent what we take, it should be always below the baseline. Why? Because if we take more solvent, whatever the compounds we have placed on those spots, what will happen? They will be dissolved in the solution. So that might be a cause that your TLC might not be a good TLC. So always remember to put the TLC, the solvent what you will take, that should always be below the baseline. Now you can see that solvent front is running running initially, or it is running at the first, then the spots are running. So now this, if you see, when I clean the edges, now it is running very smoothly. Now if you see, if you keep it for a small time, or if you keep it for some time, it will reach up to the base to the solvent front. I am forwarding the video so you can see when it reaches at the, now you can see it will, once it reaches the base, so solvent front, we will take it out. So now it reaches the solvent front. Now we will be taking out the TLC. Now you can see, now we will dry it off. This is our UV chamber where we are using in short wavelength to check whether it is UV active or not. Now you can see we have placed the TLC, what we have taken or what we have run. Now you can see, as I have placed there in the slide, is it exactly same? You can see the starting material, the co and the reaction mixture. In co you can see the starting material and the reaction mixture both are present, and here our product is there. So now this is what I told you, that this is KMnO4 charring. So now we dipped in the KMnO4. Now we will heat it to see the spores which are charged by KMnO4, which are oxidized by the KMnO4. We can see here only the product what we observe, those are only oxidized by the KMnO4, whereas the reactant, they were not oxidized by the KMnO4. So now after charring, we just you can observe the reaction monitoring. So it is showed the reaction has been completed. Now you can quench the reaction, or you can quench the reaction, and you can work up and go further. So what we do further? So what we do further? Now we do the purification of the reaction mixture. Now if you go to the TLC, now if you go to the if you look into the TLC, I can go to there also to show you. Now, if you see in this reaction mixture top, there are three spots. If I can say there are three spots. One is this big spot, below there is a little spot is there, and this blue spot. Now to separate this mixture, what technique we opt? We opt for the column chromatography. So now we can go that what is column chromatography, how we do the column chromatography. So column chromatography is a absorption chromatography. So what we do, in which here what we take a solid stationary phase which has been packed or which is packed in a tubular column, and the mobile phase, that means the solvent which will be allowed to flow through the solid, so that we will get our compound, now what we want to purify. Now the chromatography, column chromatography is of different types, but I will be explaining two important techniques, that is gravity column chromatography and is flash chromatography. So what is gravity column chromatography? What will be the mobile phase that would be passed through the stationary phase, that won't be that would be automatic, means we will put the column, we will pack everything, the column, the silica, everything will pack, and we will flow, or we will put solvent to flow on its own. So what particle size of silica we use here? We use the particle size of silica 60 to 200 micrometer, the mesh size 60 to 220. Here what happens, it takes large solvent, it takes longer separation time, but whereas the flash chromatography, which we apply pressure, that means we apply nitrogen or air to pump or to push the solvent through the column. Here the normal particle size we use, the 35 to 75 micrometer, it is very thin, and the mesh size is also 250 to 400 micrometer. The solvent is very less, and it takes very short period of time. We do very quick, the column is very quick. Now we come to the principle, what the principle says. If you see this graphical picture says, so here this is the column where we place the cotton upon upon it, if you put sand or if you don't put, that doesn't matter. If you put sand, it will just make the silica, whatever you will pour, the silica will be leveled. If there will be no sand also, it will be also fine. Now after preparation of the slurry, silica slurry, this is called silica slurry. So the mixture, to whatever the mixture we want to be separate, that we will prepare or we will pour. So how the mixture will be prepared? The mixture can be done, the mixture can be poured in two types. The one is dry loading, another is wet loading. So what is dry loading? The dry loading, the mixture, you dissolve it a very little amount of DCM or chloroform and pour a 1:3 ratio of silica to it. So after that, you concentrate it or you dry it, you concentrate the solvent. So all the compound or all the mixture will be absorbed on the silica, and then that silica you pour here. Sorry. After that, that silica you pour here to purify that. Another is wet loading. What do? If you dissolve that one and you directly load into the silica. So whatever the silica will be present here, that will absorb the reaction mixture. Then we put a sand or cotton so that the mixture which we have put it will not disturb while pouring the eluent or the mobile phase. Now if you see, this is the procedure of the column chromatography. As I have explained, this is the packing of the column, then we do the solid loading, then we do elution, then we do detection of the compound through the thin layer chromatography, then isolation and characterization of the compound. If you see here, the white layer, what it is shown, that is the silica slurry they have prepared, or we have prepared the silica slurry. So now upon it we pour the sample load, whatever we prepared, that wet or dry method. Then this top part, what you see, this is the eluent. So we pass the eluent, then we collect the fractions, then we characterize with different techniques. What happens? So if you see the process how it happens, this is a stepwise process where initially, if you see, there were a blue spot and there is a pink spot in a pink layer in the column chromatography. So after some elution, if you see, the blue layer comes down and the pink layer also comes little down, and after passing the eluent, it further comes down. Now if you see here, we collected the blue spot, and in the next part we have collected the pink spot. Now this, as I have mentioned this graphically, so sometimes you may get colored compounds or sometimes you may not get the colored compound. So you have to always check the TLC to confirm whether the spots or whether the fractions were completely separated or not. So by doing this, we separate the fractions, then we concentrate it, we go for the characterization. So what is the advantages of this column chromatography? So any type of mixture, any type of organic molecule you synthesize, we will able to separate it through column chromatography. Any quantity also, this can be vary from a micro milligram scale to a kg scale reaction also. So mobile phase means the eluent can vary from any, you can take any solvent except water. You can take any solvent, which a wide variety of solvent you can take, I mean. And that the flash chromatography, which is automatic chromatography, that can also be used to separate the spots. But now by using this, some of the advanced some of the factors that are affecting the column efficiency that I will be discussing, that means the dimension of the column, because whatever the glass tubular column we are taking, that has a fixed length and width. So we have to find the accurate length and width or ratio for the better column. Then particle size of the column packing, whatever the silica we are taking, the particle size also be the adsorbent, the particle size need to be also corrected or taken very accurately. Then temperature of the column, with increasing temperature, the elution, the speed of the elution increases, so you will get the spots quite quicker. Then packing of the column, you can, the packing should be proper. If there will be some air bubble, it will crack the column and your column may get destroyed. Quality of solvent, the solvent what we use, it should be always low viscous, means that should not be very viscous liquid, that should be very low viscous solvents. Pressure, by applying pressure, we can do the column very quickly. Then application, what are the application? As I have, we can separate mixture of compounds, we can taken out the impurity, we can active property. Let's say as sir has already discussed, if one compound is like a berry, one is sweet, one is sour in taste, so those type of compound also we can separate through column chromatography. And we can separate also the diastereomers. So diastereomers, that is little bit chemistry oriented. So if you some idea about chemistry, can know about the diastereomers. Then some advanced column techniques are also present here. That is, this is called high performance liquid chromatography, and these are the columns where in normal column chromatography we do the manual column, but we have to purchase these columns for the high performance liquid chromatography. You can see these columns, as we have these columns, these are very costly columns, one cost around 1 lakh rupees. So what happens here, this is the solvent reservoir, this is the pump, we inject the sample here, this is the column, it will pass through this column and you will get the signal or in the computer or the recorder. This mainly used for the chiral compounds, those have chiral in nature. This liquid chromatography technique only used for the chiral columns. Now after doing the column chromatography, now you have, as I have shown, one blue fraction, one pink fraction. Now as you know, the blue fraction and pink fraction, they are more in volume. So now to characterize that, we don't need this much volume of solvent. So for that, we need to concentrate that solvent. So to concentrate that, we have to use the rotavapor. The rotavapor technique now will be again discussed by Miss Sandhya. So I am switching over my talk to Sandhya Rani Miss. Thank you.
Okay, I am again starting. So we are going to discuss how we will able to concentrate our things which we get from the column fractions. So what was previously discussed by Mr. Jitendra Panda. What he said, like he has collected two fractions, like one pink fraction and one blue fraction, which is actually whose concentration is very less as these are in diluted thing. Okay, so I will just let you know that the rotavapor just it is a vacuum enable thing through this is our rotavapor, which is of Bucci R300 rotavapor we are using in our lab. So here the vacuum enables the evaporation of the mixture material mixtures at low temperature and shorter process times. Okay, and this principle is used in rotatory evaporation. That means while rotating, it is evaporating the solvents and a fast and gentle separation process for heat sensitive substances among the others with different boiling points. Okay, so rotatory evaporators are also used in molecular cooking for the preparation of distillates and extracts. Okay, so these are the different parts. You can see it has a condenser coil, chill the vapor and condense it back to liquid, and the products can be injected into the system without. Here is the injector is there, and distillate, you can see that the green things are distillate grips from the condenser coil down to the receiving flask. And this is you can see that the evaporation flask is heated by water bath and the rotation is going on. So I'm going to show you one video where you can see that how the process is going on. Okay, so guys, this is the rotavapor. So I'm starting the concentration process. This is the chiller we have, which contains ethylene glycol and water inside it. You can see, and this is the vacuum pump we have, which is generated the automated vacuum inside it. This is the water bath, whose temperature we are keeping always in 40°, and we have a digital rotavapor. You can see this is the demote condenser. This is our system. This is the display where we can change anything like the vacuum and the vacuum and the temperature, etc. This is the rota joint what he has just added, and this is my reaction mixture what I have explained before the reaction. And this is the rota clip. Now just we are going to lift it, and you can see the lift is just adjusted, and we are going to set the vacuum here. So the different solvents has different reduced pressure. That means different vacuums where they get evaporated. So by increasing the vacuum, we are just lowering the boiling point of the solvent what we have inside our compound. So I have used DCM and THF, what I discussed previously during my reaction. So I have set it the vacuum in 700 millibar, and you can see now it is rotating. I'm just fast forwarding the video a little bit. You can see it is condensing now. Okay, gradually we are just lowering the vacuum. You can see now the things inside the RB are just boiling, means the solvent is boiling and evaporating and condensing in the and collected in the collect chamber. See, the content is now less, and here we are getting our solid. Just these are just sticking in the walls of the round bottom flask. You can see it clearly now. It is completely formed the solid. Now the lift is just released, and you can see that now I have a concentrated compound. And the further I will just go for the further characterization. And the next session will be held discussed by Mr. Jitendra Kandana. Okay, now sir will discuss and show you some videos of character and other characterization techniques. So it is over to sir.
Okay, so thanks Sandhya and Jitendra for explaining beautifully a day's work of an organic chemist in a laboratory. So you can all see that what a researcher does every day in an organic laboratory, starting from putting a reaction, then monitoring the reaction, and finally purifying the reaction. So after all these are done, of course, then goes to the characterization. So we'll go for that. And yes, so these characterization techniques, and we'll see, yes, we will see that, of course, as I have told, that we'll go for this NMR spectrometer, how it is used. Of course, it's the main topic of our demonstration today. Again, all these are basic principles. I'll not go there. These are all concepts, but I think I'll directly go to the video which we have prepared for the demonstration of the, yes. Okay, so now you can see what we do first, that we have different different NMR solvents. So here you see the demonstration how the compound is prepared for the NMR experiment. So here you see, I will fast forward a little bit. So we have just, you can see we are taking the ethanol in the NMR tube. So you can see this is the NMR tube which is placed in the NMR spectrometer. So first we have to place our compound in the NMR tube. So what Ms. Sandhya is doing, that we are preparing 2 samples of NMR. So you can see that is there. And finally, you have to put the deuterated solvent. Of course, this is one solvent which is particularly used for NMR spectroscopy. We cannot use the normal organic solvents which we use for reactions, column purifications, but this is a particular solvent, of course, which is a little bit expensive. And the main difference is This is deuterated. So if you know about protons do have one isotope which is called deuterium, and deuterium solvents are used for NMR storage. So you can see now Sandhya has prepared the sample, and then so yes, you can see the sample is now prepared, both samples, and for separating or identifying the samples, we do give different names. So here I will take you to the very NMR lab what we have. You can see here. So I'll just explain things there. So first thing you see, this is our NMR lab, which is located at the very this tea stall near the banyan tree. Something is placed here at the gate. You can see, because we have nuclear magnetic resonance, a very strong magnet is used for the spectrometer. So you can see, you should not be taking any of the material which is ferromagnetic in nature, which will get attracted towards a magnet. So here you can see, some ornaments, your watch, the keychains, your these cards, and all that you should not be taking. So there is a no entry sign for all these materials, ferromagnetic in nature. Then let's move forward. So of course, then you get inside the room, and there is the one. So what is this? This is of course the main equipment of NMR spectrometer. What this comprises? This comprises a tomb-like structure. Inside it, there is a big magnet. And of course, because incidentally, I am in charge of this NMR spectrometer, I know how expensive it is and how difficult or tricky it is to maintain the magnet. So this magnet is highly sensitive. We need to maintain it. And you can see there is something here. This is an auto sampler. Of course, this is one accessory which was added, afterwards. What is the work of this? What this does? It automatically takes the sample. You will see in the video to the yes. So there is the auto sampler. You can see. So we have placed our okay. So as per the video, I'll be explaining. So yeah, I just want to go first here. Okay. So here something I would talk about. The NMR lab is maintained at a low temperature. There is reason behind it, because there are many parts of the equipment which gives some heat energy, and heat is not good for the equipment. Okay, and you will see incidentally that we use different cooling solvents like liquid nitrogen, liquid helium to maintain the magnet. Okay, so that's why, to help in that purpose, we have the AC is there, and you can see these are the containers. These are the containers which we use to store liquid nitrogen. And in fact, every week we need to fill 50 liters of liquid nitrogen just to maintain the magnet very well. And then there is, of course, we have some batteries, because we don't want the NMR, the scanning gets affected when there is no electricity. So we have additional system for UPS which supplies the electricity. And then here there is something we should be knowing, that we have different gas cylinders. Mostly there are nitrogen cylinders, and there are some air cylinders. So there are of course different purposes, because when we fill the machine with liquid nitrogen, we need to push the liquid nitrogen, because if you just remember the magnet, it is at a certain height, and we cannot pour liquid nitrogen. The temperature of liquid nitrogen is minus 200 degrees centigrade. So we cannot just lift it and put it from the top. So what we do, we put pressure from bottom so that it pushes the liquid nitrogen to get into the equipment. So here this is, and you can see, of course, there will be a demo that how the sample moves. Okay, so here you can see something, helium fill-in-4. So that means there is liquid helium, which is of course very, very expensive. To tell you the price, 1 liter of liquid helium costs us 2,000 rupees. So that means you can see in that comparison, of course, helium is not as abundant as liquid nitrogen. So what we do, we fill helium twice in a year. But to maintain the helium or to keep the helium, helium consumption low, what we do, we cool the helium by liquid nitrogen, because liquid nitrogen is relatively cheaper than helium. So you can see this is the inlet of liquid helium. So this is again, we have shown the auto sampler here. So, this means that even if you are not there in the NMR lab, you can still continue your experiment, because, this is one additional system which automatically does the, put the samples in the TOM and get the NMR experiment running. Okay, so you can see there was something here, and this is one system, because you will see you will give different commands in a computer, and that command, so that command, that machine what we saw here, that will translate the command to the active, physical activity. Now let's say we put some command like eject, SX eject. So that means the sample will be ejected. So that machine there, that intermediates between the command and the physical activity of the sample. So this is one part of the NMR equipment which is called console. So this is very much the machinery part, where all these processes are controlled, processed, and you get the spectrum. We will see all these, but of course this is a very tricky technique, which in fact I'm not very aware of the techniques here, but we know that this is the very much the process which does everything inside so that we get the spectrum out. There are different parts, but you can see here, yes, there is this AQS, and then down there will be BSMS. So here we have BSMS. So they do all the, this conversion. And here it is something here, which is a air purifier, because sometimes you will see we need some pressure to put the sample or to make the sample going up and put inside the tube. So we need some pressure. And that time what we use normal air, but without moisture, because once moisture goes inside at liquid nitrogen, it will get condensed, and the sensitivity of the machine will go or will be lesser. So that's why we use one air purifier, and which provides dry air to the system. Okay, so now you can see what we did here. So there was some sample inside. So what we did, that we need to remove that, and then finally we'll start from the very beginning. You can see there is a sample, and what we'll be doing, we'll be putting in the auto sampler. So that is this blue color is called the sample holder. So that will hold the tube, and there is certain measurement. There is certain measurement you can see here, that you need, that should be the depth of the tube going down through the sample holder. So then we put at a certain place, the sample positions are numbered. Then yes, so you can see different black marks are there. So accordingly, you need to have your solvent height. for a better NMR spectrum. So now this is the computer here where we need to give different commands for the NMR scanning. So here it is. Of course, a physical demonstration would have been very nice, but we still, I hope I can make it a bit convincing. So now here you can see I gave the command. Now it is taking the sample from the 16th folder. So now there is the pressure. This pressure is coming from the dry air as the equipment providing the dry air. Now the sample went inside. Okay. Okay, so I need to make another video here, which is better. Okay. Yes. So now you can see we will give different commands and try to explain that how NMR experiment is done. So you can see something here moving. Okay. So that is called the simming line. The simming line. What it shows that your compound is not well settled in the NMR spectrometer. Now you can see with a command, what I did, yes. Okay, so here, yeah. So what we do first, we try, if you remember that Miss Sandhya prepared the sample with a deuterated solvent. And then what you need to do in the NMR spectrometer is to assign the solvent. So there is a list of all solvents. So what we need to mention here, lock and with the solvent name. So once we do that, you can see then the point here that will get locked and you will see the change, what happens there. Now it is just trying to recognize the solvent. And yes, now you can see something, it got thinner and then it will go up. Yes. Now you can see the uniform here and then finally it is going up. So that means the equipment now has understood that you have a solvent down there and which solvent you have. So now you can see the simming line went up. Then to get a better spectrum, we need to do further simming. For that one, what we do, we put another command. Of course, this, for example, in my PhD days, we did it manually, this better simming. But now with, techniques improved every day, every month, now this can be done. This can be done automatically. So you can see something was given. Now this auto simming is going on. During this auto simming, if you remember this BSMS, you can see there is a term BSMS, which I showed you the equipment. Now this process is all going on here. During the process, the simming line is completely down. That means it is unlocked. Okay. With that one, the simming for each axis is getting better and better. So you can see the line here, which was here, will go further. That means the sample is done. The simming has been very correct. You can see the line was here before, but now it has gone very top. Okay, so you are expected to get a very good spectrum. Okay, so then we have further commands which is called RGA. Do you see that video? Just a minute, guys. I'm just checking. Yes. So now we give a different command which is called RGA. So that means it is receiver gain analysis. The use of this command is to know the concentration of your sample. Okay, so in this process, the spectrometer will understand how much is the concentration of your sample. So in this process, you can see once you put this, automatically it will do the receiver gain analysis. Yes. Okay. So and in this in this time, what you need to do, you need to create a file for your own sample. You can see what I did. I did Control N. That means a new file will be created and will be asking about your parameters. So of course, you can give your sample name, you can give your experiment, you can give your solvent, and everything you can mention here, and then get the page for your spectrum experiment. So here, that is something I am doing here. Yes, I took it little closer here to show something. You can see RG. That means it is the receiver gain. So after finally this through RGA, the spectrometer automatically analyze the receiver gain analysis as 203. Okay, so then you can see there is number of scan, which is 16. That means 16 times the spectrum will be scanned. So that we'll be seeing now. So once all this done, we start the experiment. You will see what will go on. The video maybe is a little bit blurred, but I hope we still can understand something out of it. So the receiver gain is finished. RGA is done. Now, yes, I would like to show something here. Before it was 203. Now, when I did RGA, because that is the default value, but when I did the RGA, it got changed to 90.5. That means there was a more concentrated sample. If the sample is more concentrated, the RG value will be less. So it will be an indication that how strong is your sample. Okay, so once that is done, what we need to do, we need to start the experiment. Because during all this time, now there is number of scan, you can see NS, which is normally people put a multiple of 4. You know, you can give 4, 8, 16. You know, that is just the way it should be done. So I gave 16, and now I'll start the experiment. This is another one, DS. DS means, it means dummy scan. Of course, you understand dummy means. So it's not a proper scanning. It is just dummy scanning. That means during that time, the sample will mix with the electromagnetic radiation, with the magnetic field which you are providing from the big magnet. So that is for dummy scan. And once you start, so you can see dummy scan is 2. You can give any value. If you want longer time for your mixing, you can give long, but normally it is not necessary. Okay, so now finally the start of the experiment is ZG. There are different commands fixed for it. So now once you give ZG, the experiment is set to be started. Now if you see here, the dummy scan was 10. So you can see just it is going -9, -8. But the proper scanning, there is nothing here in the page. But once it will start after 0, you will see something there. Okay, so now you can see here. So this is called FID. Okay, it's a pre-induction decay. So this is how it starts. So now, of course, with time it will get stronger, and finally you will get the spectrum which looks like this. I think I'll go little forward here. Okay, so now we started to do because if you remember, there were 2 samples, so we started putting the other sample. So it is the very same. You can go on doing it, and finally you will get the spectrum. Yeah, so you just need to follow all the procedures again and do the You can say, a very good looking uniform FID we obtained in DMSO sample, because that is the properties of DMS there. The sample was very soluble, so that's why we got a very good FID. Yeah, so now the sample was ejected. Okay, so then you can see something we also tried. We tried to take the carbon NMR, because if you remember, I told before that you can have protons analyzed, you can have carbons analyzed, you can have fluorine, phosphorus, all these atoms you can analyze. So we tried also doing one carbon NMR that is there, but it will be similar process, and there it goes, the NMR. I think what we'll be doing, we'll be taking this in a different different software to analyze the NMR experiment, and I would like to show you how the NMR spectrum is analyzed. Okay. Okay. Yeah. So now I'm just trying to get the. I would just like to know how much time we can take. Of course, it is going to be 5. Can you take 15 minutes more?
Yes, sir. Yes, sir.
Okay, thank you. So this is one software, of course, by which we can analyze the spectrum, and I would like to give you a demo that how we analyze the spectrum there. Okay, so you can see what we did. This is the spectrum how we get. Okay, so once we get the spectrum like this, we have different one. If you just remember the slide where I am discussing the principle, I had the spectrum of ethanol, and here it is set. We can do few things. I would like to show you how this looks if we zoom up or if we zoom in the spectrum. Here, okay. Yes. So now first what we need to do, of course, we know which solvent we took. So there are peaks, and in fact, a lot of research has been done that where the peak should appear. So what we need to do, we need to click in there, and actually what we have already processed. So it is 7.26. That is one chemical shift. It's a little bit chemistry here, but you can ignore it. But you just should see how it is applied or how it is processed. So once we do that, all other peaks, because mainly these peaks are there, which is for your compound. In this case, we have ethanol. So then I will again do something. Yes. So there are few commands. For example, if we click I, it will go integration, or otherwise we have integration here. So we can do that. Now I did here. So I have to integrate the peak just like this. And then what I need to do is to edit the integral, because I know, because you will have some idea about your compound. Of course, if it is completely uncertain, there are ways, but if you have some knowledge of your compound, then you can do that and process the peak. So I know there will be 2 protons coming at this point. So once we do that, you can see something, it was 1.5 before. Yes. There it was 1.5 because there it was 1 because all these peaks are relative. So once I make it 2, it automatically turned to 3. And if you look at the structure of ethanol, maybe I can go here. Yes, I have here, you can find, yes. So I have ethanol here. There is, that compound which I showed there, I gave this 2, it became 3. And if you can see, I have 2 protons here, I have 3 protons here, and I have a single proton here. Okay, so you can find here, I got 3, I got 2, and here this is 1. Okay, so that is how I can characterize that I have ethanol molecule, because of course there are certain more things where maybe one organic chemist can explain that why this is coming here, why this is coming there. So there are certain principles, but this is how it is done. Then here I would like to mention one more thing is, if you take the same compound in a different solvent, because here it was CDCl3, deuterated chloroform, and here it is deuterated dimethyl sulfoxide. Now you see something happened here. The same compound, you got peaks at different values. And that is because we always know 2 organic molecules interact with each other in a different way. So this molecule interacts with CDCl3 in a different way than with a DMSO. Hence, we are getting different peaks. But that is very well known, and even you can practice, or you can analyze what kind of interaction this is with the corresponding solvent. Okay, so then I will go to, because we are running out of time. Yes, and you can see here, this is the carbon NMR. And if you see, of course, this is for the deuterated solvent. And besides that, we have 2 carbons, carbon A, carbon B. And we have, in fact, 2 peaks, one for carbon A, one for carbon B. So this is how also the carbon NMR can be analyzed of a certain compound. So I then would like to move to high resolution mass spectrometer. What it does, it gives us the mass of the sample. Okay, and we will see that how it is helpful. And for that, we have a video so I would like to take you through the HRMS lab, which we have in Peer building. Yes, which we have in Peer building, and you can see that yeah, it's a 9-minute video. I think we will. So this is the equipment. Of course, last year it was purchased, and it cost around 1.7 crores. So you can see the various equipment. Of course, I'll not go in very detail of how it runs, but you can see little bit how the experiment is done here. So there are the different accessories of the HRMS. Yeah, there is a vacuum pump, because what it does, the unnecessary fragments that takes out. And we have the operator, Mr. Paramanand here. He is, of course, analyzing all the experiments. So now you can see the sample preparation. What it does, it takes only 1 milligram of sugar. I think this is something all of you might be needing, that if something unknown is there, you can take the mass, and from the mass you can expect that how big is the molecule. Of course, if it is a very big molecule, then you go on to have different experiments. For example, you can go for NMR as well and see that which might be the compound present in your sample. So what he did here, he tried to make the sample soluble in the solvent. That's why sonicator was used. And now he is filtering it out, because the HRMS equipment doesn't like insoluble part, because it will get stuck in the column. So it was filtered through a syringe filter. Yeah, so now you can see that. So it was filtered into a another sample vial, which will be placed in the spectrometer. So I'll take you there. So here you can see what he is trying to do is to dilute the sample, because HRMS is so sensitive. It can even give you the spectrum of few micrograms. 1 milligram sample can be 50 times diluted to get the NMR spectrum, but it is always advised that a strong sample should not be injected. So here is the way the sample was put in the HRMS, the spectrometer, and now this is the monitor where again different commands will be given, your sample name, and then finally the NMR will the spectrometer will give you the spectrum. Let's go there. Yes, now you can see something is coming up here. The different peaks at different M by Z. So this M by Z is some principle, but what is important for us to see where is this M by Z. So yeah, some sample was given there. I'll take you also to a spectrum where we'll see that how we get our data. I hope that is there. Yes. So now here we have a sample. So you can see that what we got from this compound. This is how all compounds will give you the HRMS data. So there is the compound here. Of course, when you have the compound, you can calculate the molecular mass. So here you can see it has been written the exact mass, which you can calculate. But then what you get is the observed mass, because sometimes there will be, of course, we know there are different isotopes. There are some that is called the errors of human error, because this is a message. So when it is operated, there will be some errors, and depending on that error, you will get a value. For example, what we can see, or what we should be happy, that a mass of 305.1627 did give us a peak at 306.170. Now you can see there is a mass difference of 1. Why it happens? Because we, in this process, we inject some acid into the sample. So when you inject some acid, that protonates some of these atoms, giving you a mass for M plus S. If M is the mass of the molecule, then you get a value for M plus S. Then something you can also see that there was another peak, which we got at M plus 23. And we know that 23 is the atomic mass of sodium. So when this is, because there are few additives which are sodium salt. So if sodium plus is there, also that can attach to the molecule to give a mass of M plus Na. Then there is M plus ammonia plus sodium plus water, because water is used. There is sodium salt. There is also ammonium salt. So once they are there, they can also get attached to your molecule, giving a mass. So what do we know? What is the information we get from here? Can we analyze the peaks as per the mass of the known compound? If it is there, then it can confirm that you have your compound. So I think with that, we came to the end of today's meeting. And again, I would like to thank the organizers for the invitation, so that I could share some of the chemistry, which is very much there in food science, and some of the equipment which we use in our daily research life, and hopefully that will be helpful for the researchers in food process engineering, and they can always use this equipment for the advantage of their research. And of course, in any case, they can always approach to us for further understanding and proceed. Thank you everyone again. If there are questions, I'll be happy to answer. Yes, so of course, again, I already thanked the participants and the contributors to this talk. And finally, thank you all for your kind attention. So if there are questions, I'll be happy to answer.
Thank you, sir. I'll request to all the participants, anyone having question, please raise hand or drop questions on chat box.
I think there are few in the chat box. Okay, so it's not questions, but there were, yeah.
Please raise your hand, participants.
Participants, those who are willing to interact, please raise your hands.
Of course, I understand this is something different than what they might be expecting, but at least you can see the interlink between food and chemistry.
Yes, sir. That was interesting presentation. We learned a lot from this presentation, sir. I hope this presentation was very much useful for researchers.
Yes, I hope that.
Yes, sir. There is. Thank you so much. Thank you so much for sharing your knowledge with us, sir. Thank you.
Thank you. Okay, so there are compliments, but let's see if there are any questions.
We'll wait for another 2 minutes, sir, I think. But participants, please raise your questions. You can type either in chat box or in question and answer session. Or if you want, you can directly interact with our expert. I think there is no question from the audience, sir.
Okay.
Maybe if I get any questions from my audience, I will forward.
Yeah, always that can be emailed to me as well.
Thank you, sir.
Any question or any help, let's say in that regard.
Yes, sir.
So that will always be welcome.
Yes, sir. There is one question from our participant.
Yeah.
Sir, I have a question, sir.
Yes, please.
Sir, can we analyze mineral in NMR spectroscopy, sir? Mineral analysis can be done, sir.
Okay, very good question. But unfortunately, no. I would like to tell why no. Of course, when you talk about mineral, we need to make it a solution. Then one more thing, of course, it's not a complete no, but there are solid state NMR. And, unfortunately, we don't have that spectrum. Are not soluble in anything, right? They are solids. So those compounds can be scanned in solid state NMR. There is a technique where you don't need to make a solution, but you can just go with the solid compound and get your analysis. That is possible, but not with the present spectrometer what we have at NIT Rourkela.
Thank you, sir. There is another question.
Yes.
What will be the difference between FTIR and NMR analysis?
Okay. Again, I really appreciate, because even as a teacher, I always ask students to ask questions, because then only, sorry, I'll be taking you there. I had that one. Yes, I have here. So what you can see, what is the difference between FTIR? So here the infrared spectroscopy, and then there is NMR here. Of course, I hope I probably don't need to explain now that what will give or what NMR will give us. Or maybe in this compound, literally, you will get all details of from the for this compound from the NMR spectroscopy. You can, and in fact, I have done it from NMR beyond any doubt. You can characterize the structure of this compound, but in IR or FTIR, what you call Fourier transform infrared spectrometer, if you do this, what information you will get? I have pointed out here. What is that? Is the functional groups. For example, here we have amide. That means only the amide will be noticed. The C double bond C will be noticed. But now, for example, the C double bond C is connected to this amide will not be noticed, or will not be noticed with great accuracy. That means infrared spectrum will give some information about the molecule, but NMR spectrum will give all details about the spectroscopy. That's why, that is probably the utmost equipment for one organic chemist, the NMR spectrometer, that has been so highly developed, and it is still developing, that it has superseded the use of UV spectroscopy, IR spectroscopy and all that. But still then there is use of IR spectroscopy to get these ideas. For example, the functional group, you can see the hydroxyl group that can well be observed in NMR, also in IR. So nowadays, IR spectrum is one supportive data to the very well-known NMR data. I hope I answered your question.
Yes, sir. There is another question in the chat box. I will read that for you, sir.
Please.
Sir, please explain why only hydrogen used in NMR spectroscopy.
Okay, very good question. So for that I'll take yes. Here it is. So what happens, your questions brings me a little bit talk about the principle of the NMR, and which I will be very interested to talk to. So what it does, if we see the elements are given, hydrogen, this is deuterium, this is carbon 12, this is carbon 13 isotope, then nitrogen 14. So they all have nucleus. I'm trying to tell in very simple way. So they have all nucleus. So when the nucleus will have some spin, because of course you guys know nucleus will have neutrons and protons, and all of them spin. Proton is a charged particle, electron is a charged particle, neutron is a neutral particle. Okay, so now they spin. When they spin, something physics tell already that a charged species, when it spins, it creates a magnet. Okay, it creates a magnet. But now, when you have more protons, for example, let's say talk about carbon. So carbon is 12. That means in the nucleus, it has 6 protons, 6 neutrons. So when you have 6 protons, something also we know that 2 protons, they pair with each other so that the spin is cancelled. So when there are 6 protons, there are 3 pairs. So if there are 3 pairs, the total spin will be 0, because one, in a pair, one proton will cancel the spin of the other proton. So that will be, the spin will be 0. You can see the nuclear spin is 0. If the nuclear spin is 0, that is no more a magnet, because it is not spinning. The overall spinning of the nucleus is 0. So it is not a magnet. And if it is not a magnet, now please think about when I was telling the equipment, there is a big magnet. Okay, so what actually it does, the interaction or the collision of the external magnetic field provided by the big magnet with the nuclear magnet, the small magnet. And you can see here the proton, which is having a half spin, because it has only one proton in the nucleus. So it has half spin. So when it has half spin, it is a nice tiny magnet. And that tiny magnet interacts with the external magnet, brings 2 fields, and then your EMR, this electromagnetic radiation, which we are providing in radio frequency region, that will excite the molecule. not the molecule, that will excite the nucleus. So that is why we will see the property or the phenomenon which occurs by the excitation of the proton nucleus. Okay, but not only proton. What you asked, not only proton. Carbon-13 does the same. Fluorine does the same. You can see fluorine here. Phosphorus does the same because they have non-zero spin. They have one odd number of nuclei in the nucleus, which gives a total positive spin of the nucleus. And as the nucleus is a positive particle and it spins, it will create a magnetic field. And that magnetic field will interact with the external magnetic field, giving two different levels. You know, that is something quantum chemistry or quantum physics. It will give two different levels. And that is the very basis of any spectroscopy. You talk about IR spectroscopy, you talk about UV spectroscopy. Always what is there? There are two energy levels from by. You can see, you know, this is a very basic principle. Can or the nucleus or the vibrational radiation will be consumed. And when it is consumed, what you see, how much is consumed, at what wavelength it is consumed. From there, you get the spectrum. Okay, I hope again I answered, you know, this in a very simple way I tried. But of course, the nucleus, which will have non-zero spin, for example, proton, carbon-13, phosphorus 19, or fluorine 19 or phosphorus 31, they will have NMR active nuclei and they do spectrum in NMR spectrometer.
Thank you for explaining, sir. I hope you understood that.
Yes, I hope the same.
One more question.
Yes, please.
Can we use NMR spectroscopy to quantify the vitamins?
Yes, it's a very good question and one advance. I appreciate it. Quantification, yes, it is, and in fact, we do here. So again, just to tell little more detail, what is meant by quantification? Quantification means or in liter or anything. So you have to quantify. And we in fact can do that. How do we do it? We take a reference value. Okay, maybe I really. This is the spectrum of ethanol. Okay.
Yes, sir, you are audible, sir. Sir, am I audible, sir?
Speak.
Kiran? Sir, am I audible to you, sir? I think there is some network issue. Making panelist. Time.
Hello.
Yes, sir. Now you are audible, sir.
Yeah, I think there is some issue with the internet.
Sure. Okay.
Yeah. Progress. So yeah, I think now you can.
Sir, one more participant want to interact with you.
Yeah, please. I need to explain that. Can you see the slide?
No, sir. Slides are not visible, sir.
Yeah. We can actually. Okay. Hello.
Yes, sir. You're audible, sir.
Yes. Yeah, I think there is some internet issue. So I'm again just talking through my phone. I hope everybody can hear it.
Yes, sir.
Yeah. Can you please repeat the question? In the meantime, I just. Yeah, the vitamin C. Yeah, the vitamins. So of course we can quantify. Yes,
sir.
we can quantify. So what we need to do? We need to take a reference. Okay. So what we a known compound you can add with the NMR sample you have prepared. Now you can get the peaks relatively. So you get the peaks relatively and you know the weight of your reference, and accordingly you can quantify, you can find the weight of your sample. So that is how, in fact, that is done very much. It is called NMR yield. In a reaction, when we cannot isolate something, we always try to find the NMR yield of the reaction in this process. So you just take one reference compound of known weight and take the NMR of your mixture and find the weight of your sample. That is how you can quantify.
Thank you for explaining that, sir. I hope
Thank you.
you understood that. This session was very much useful and you have taken from the basic. I hope the students will be benefited out of this. Thank you for sharing your knowledge, sir.
I hope, and thank you very much.
Thank you, sir. So with this, we are closing today's session. We'll meet tomorrow morning by 9 o'clock. So I request all the participants to join Zoom platform by 8:50. By morning 9 o'clock, we are having an interesting lecture from.
Okay, so again, thank you everyone for the nice 2.5 hours. I felt good by interacting with all of you, and I hope this presentation will help you in some way.
Definitely, sir. Thank you so much for your contribution, sir.
Thank you.
Participants, I request you to join us tomorrow morning by 8:55. Tomorrow morning by 9 o'clock, we are having a interesting session related to journey of agri-food processing sector, consumer perspective by Dr. Venkatesh Mehta from Department of Chemical and Bioengineering, University of Saskatchewan, Canada. Thank you.